that one is fake compared to the good one.
By the way, we're live.
We're live.
Hi guys.
Hi guys.
There's someone out there. This is so quiet in the chat. Did guys know that we're on? Well, they should have told them.
Well, it should be on the normal one.
Yeah.
Oh.
We're talking.
Can you try on your phone?
Yes, what, on the phone?
If you're online, guys, if you can hear us, please let us know in the chat.
We cannot see anything on the chat right now.
Oh, there the guys. Okay.
Oh yeah.
Perfect.
Just a delay.
Hello, David. Hello, PM Chris.
Hi guys.
Just before I forget, and we'll try and remember mentioning this when there's more people in later. So, hi.
Hey, everybody.
Carlos as well again.
Yeah, well enough.
Well enough. Well enough. So, the next live video, which is in 2 weeks' time, is on around the 6th of April, something like that.
Yeah.
Thereabouts. First weekend of April. And then normally there would be one 2 weeks after that. But
Yeah.
Detlef's going to Germany for a couple of weeks. So we will still do 2 live streams in April, but it'll be the 6th, and I think it's about the 20-something.
Okay, so we jump over.
Yeah, let me get the correct dates. Let me just.
My phone is lying on the supercomputer thing.
So let's just check this right now. Oh, the supercomputer!
Oh,
broke the supercomputer.
Yeah, you broke
it's gone.
the supercomputer.
It's this tiny little thing. It's cool.
Yeah.
You guys know this from Big Clive. He has this on the wall behind him, and yeah, this is one with a microcontroller.
So can we just get the? Let's get a.
Yeah. What date do you fly?
Well, in fact, I can actually do it on here.
It's gone.
I can do it on here. Let me just tell you what dates we have. So I mean,
You have OBS. On
Yeah,
the phone as
with
well?
OBS.
you can put this on as a second video for us if you
Yeah,
want.
I'll get you as a second video.
I'll just get the some of these
Cool.
YouTube things.
We'll
come
fix
up
that
for.
later or next time. No.
So calendar.
You have one built into Windows. You know.
Oh, do you have one now? Oh, see.
It's in the upper right corner.
Do you know, I've never done that. I always just do this and that. I've looked to see.
Yeah.
Calendar.
I've never Googled that calendar.
Okay, I always Google calendar. Okay, so just to confirm that in April, the 2 live streams will be on the 7th of April and the 28th of April.
Okay.
Rather than the 7th and 21st. This is because Detlef is in Germany on holiday for a couple of weeks.
Taking it easy from us.
Yeah.
Yeah.
So guys, put that in your diary.
So 7 and 28.
8 in April.
Yeah.
Not bad.
Yeah. So that's that.
I get. When is Susie going to Sweden? I'm free for 2 weeks from the family.
Okay.
They're going to Sweden
Hello, Dutch.
to renew passports and stuff, and
Right,
I
my
don't
friend.
need to, so I'm staying.
Okay. So, shall we start by blowing something
Hi
up?
Dutch. As long as it's not too smelly, because I'm still quite, let's say,
Okay.
I'm detoxing, and if it smells really bad, I'm going to throw.
Well, you shouldn't do.
Okay, live throwing up on the video. Woo. No, we don't need that.
No.
Please, no. Don't.
No, I'm was on meds for a few days ago.
Well,
It depends on what smell.
we have here.
Now you have to do the-
Yes, I can do it
With the
now from here.
microscope there.
I can do it from here now.
I'll put it in shots.
Yeah. Detlef no longer has control of this.
Yeah, the microscope has moved to the other PC, and
Yeah.
Full screen preview.
Yeah, that was the one. Full screen projector.
Project, yeah, and to the screen.
You have to make this.
No, you don't.
No, it works. Honestly, it didn't work.
Well.
Literally.
There we go.
ooh, okay.
So we have a 1N4007.
Yeah, the most common one.
The most common one. The one
That's a
that
good one, Dutch.
the good one. 1N4007. Come on.
Yeah, no, I'm trying not to. I promise.
400. I can't even turn this thing round.
4007. Yeah.
Honestly, it's a 007. There.
Yeah.
So
License to be blown up.
I was making a video about diodes for beginners. Yeah?
Okay. Yeah, I saw that.
And at one point, I connect the diode to a power supply and set the power supply to 5 amps and put 5 amps through the diode,
Yeah.
and
Little thing?
it starts smoking.
Yeah.
Yeah,
No surprise there.
but there was something interesting.
I could have told you that.
Right, so it starts smoking. So what do you think happened to the diode?
Depends on the polarity, right?
Oh yeah, it has to be in the forward bias. And the reverse
Yeah.
bias, nothing happens.
Yeah, exactly. That's what
Obviously.
I was going for.
Yeah. So can we get some background behind us, Dad?
Background?
Yeah, on the image, like rather than just.
Oh,
I
put
can't
that.
use the handheld in
Yeah.
Oh yeah, that works.
That's it.
Let me try to zoom out. There must be a zoom out somewhere.
There we go.
There we go. So we have some voltage. Yeah.
We can see something now.
And what we're going to do is we're going
So,
to turn the current down.
okay, we have 15 amp. 15.
Well, this is actually a 10 amp supply.
Okay.
But I'm actually going to turn it up to 5 amps because I was actually using a 5 amp.
But the voltage, what,
Well, it doesn't matter what the voltage is. It's 5 amps flowing through the diode. Yeah.
even at low voltages.
Well,
The voltage will be.
at the moment.
Oh yeah, right.
At the moment, I'm just
Four.
short. Oh.
You did short it.
No, they just jumped off.
Yeah.
So at the moment, I'm just shorting leads. Yeah.
Yeah.
And I have 5 amps. So we'll put this onto like a little stand or something. Yeah.
You don't want to burn a hole in the table?
Sacrificial diode over there,
The
guys.
sacrificial diode. Yeah. So the first thing we're going to do, if we take the sacrificial diode and we take a multimeter in diode mode and measure the diode.
Okay. Yeah, sure. I should be able to.
Yeah, turn it to that, and then you hold this so it goes bleep, bleep, bleep again. That's it. So
There we go. Diode mode.
So that should read like a diode.
Yeah. So 0.56.
0.56. Yeah.
Yeah, that's normal.
That's normal. So we'll take our diode.
It's alive still.
It's alive, but we haven't done anything to it yet. Yeah.
Yeah. It won't be for long.
It won't be long for long. This is the point. So if we zoom in on our diode, well, actually, Carlos, you have to do this. It's
Yeah,
your
sure.
Anyway, I'm sorry.
I've been off work. For
Can we get
3
nice
weeks.
and close? Nice and close, Dad.
Yeah. So
I'm get closer.
okay. Okay. There we go.
We're passing 5 amps through it.
Yep.
Oh man.
Now what happens?
It will hit up
Magic smoke?
eventually, and then it will die.
Well,
It's 6 watts, 6.5 watts.
is it heating up enough to smoke?
No, not yet. I don't feel anything. Let's go for the camera. If it doesn't die on me before.
It's dropping 1.2 volts across the diode.
Wow.
Yeah, so that's the forward voltage, right?
That's the forward voltage, yeah?
That's a lot.
Is it getting hot?
Not really. Oh yeah. Oh, 170.
170. Okay.
172 degrees.
Yeah.
I call this.
Okay, right, take the power off it. Take the power
Let's
off.
see. Yeah, it's at 170.
172, okay?
Yeah.
That's a 1 amp diode, yeah?
Yeah.
Right, measure it in diode mode.
Should be kind of dead, right?
You'd think so, wouldn't you?
Yeah.
I know the story already, so that's why I'm shutting up.
Well,
Oh, it is.
well, that's interesting because when I did it before, it still read the diode and still worked.
Yeah. So it probably depends on the time.
I had smoke coming out of the thing. Well,
It still worked.
well, I'll tell you what.
I didn't see that.
I have like a different brand of.
Oh.
No, I didn't show it in the video. I thought
He's
Okay.
not giving up here. He's
I'm not giving up. Try another one, which appears to be a different make.
Yeah. Okay. So this, yeah, it looks different.
Most different. Just measure it as a diode.
Yeah. First, let's hook it up here. So
Yeah.
it's easier for me.
Measure it as a diode.
Yeah. Oh,
Oh,
Hey, Chris.
is it?
oh,
Did it go out from diode mode?
try it. Measure it as a diode.
Now it
Yeah.
works.
Measure the one that we just burned.
Yeah. Exactly.
Told you.
Ah,
Look, look.
it's actually
So that diode which was sitting there for quite some time,
yeah.
it's still a diode. But measure reverse. Reverse voltage should be open.
Yes. Yeah, it is.
Yeah. Measure it forward again. It works.
So, so the tolerance is really high then.
So 5. Well,
Okay, it went up in
well, let's try again. So let's measure this one. This is a different make.
yeah. 5.68. Yeah.
5.68.
5.68. Okay.
Well, actually, out of interest, go to voltage range.
Yeah.
We'll apply the power again and measure the voltage across the diode, across the crocodile clips. Yeah.
Yeah. Okay.
So you put them on and then measure the voltage
Okay.
across.
I'll try to keep everything in shot. Okay. Okay. You can't see the.
Okay, nice
Okay.
spark.
It sparked. Okay.
Can we get it on the
voltage.
multimeter? You got the clip in the way of it.
1.4 volts from the scope.
1 point. Oh, ow!
Sorry.
1.15.
One
Oh yeah, it's This starts to smell.
Is it going to smoke?
Yeah, it's 1.1.
Dutch, be grateful that you're not
Well,
here.
well, shall we increase the current a bit?
How much? 5 amps?
No, no, give it six.
It was
6.5 amps.
it was at 150 degrees, 70 degrees.
Well,
already.
oh, smoking. Can you see the smoke coming off it?
Yeah, okay.
So this will be above 200 degrees.
Okay, right.
Yeah,
Right, now take the clip off.
Yeah.
Right.
Easily over 200 degrees.
Even if there's smoke coming out of it, yeah? Go back to diode mode.
Even the clips were kind of hot. So yeah. Okay, there we go.
It's on. Still works.
Yeah, but okay, so
Oh, let it, yeah,
It's
let it
cooling
cool down.
Waited for
Yeah.
for the temperatures.
yeah, it's cooling down, so it's actually recovering.
Yeah, recover.
So okay, so tell me.
Maybe we should reverse it, leave it open.
Yeah, no, it won't. Otherwise, it wouldn't show a
It
jump.
does, but it's open.
Yeah.
And
Oh,
then-
yeah.
and then
I mean,
forwards.
it won't be dead.
Yeah, well, it's going back to
So
normal.
it's recovering. So okay, so that leaves one question though. How do these die inside power supplies?
Yeah, how did he die inside power supplies? We've just shown we can stick 6.5 amps through a 1 amp diode till smoke's pouring out of it.
And
Take the
still
power off
alive.
and it still works.
So it has to be continuous over a long period of time.
Well, I suspect it's even more current than that.
Yeah, but you were pumping in like 7 or 8 amps.
6.5.
Yeah.
Well, the power supply goes to 10 amps. Shall we try that?
Was think
What do you think, guys? Well, shall we try 10 amps, see if that kills it?
10 amps. It should, because the casing will start to
Well,
disintegrate.
smoke was pouring out of it.
Yeah, but the casing still survived.
Any theories on your part?
They've gone very quiet. They've gone very quiet.
Yeah.
Yeah. So okay. So let's see. Could it be a voltage spike that kills it? A high voltage spike instead.
These are rated for 1,000 volts.
Rated for 1,000 volt reverse.
Yeah. I know in reverse, but forward.
Must be a
How's it read-
more
how's
current spike then.
How does it read now
Yeah.
it's cooled down?
Yeah, it
Well,
should.
no, it's that it's cool now.
Yeah, it was 5.68 when.
Chris wants to see blood
Okay. it was-
again.
yeah, no, really.
Can we get on the meter?
Okay, so let's see. 5.39, 5.4. Yeah, so it's climbing still.
It's still climbing, it's still recovering.
Yeah, so it's still hot. Not really.
Well, let's try another one. I have quite a lot of these things.
Yeah, I can see
The
that.
editorial is most current ratings of a device to maintain their characteristics. They will take more, but not guaranteed to still meet them.
Yeah.
Yeah, that's what I would go for. Yeah,
Yeah.
I won't trust this diode anymore. Yeah.
Yeah, pretty much. It won't survive that.
I
long.
reckon there's a 1 amp, 1,000 volt there, that'll be fine. Maybe we can take the 1,000 reverse, but we can't easily test that.
Yeah, 1,000 volts. Yeah, that's going to be hard to
Okay, so-
pull off.
So what's this one read before we
Oh
start?
yeah, maybe that's a good idea.
After we've this meter, won't I? So we can do the try.
Yeah, I'm trying to get both.
There.
There we
Oh,
go.
good. Yeah.
5.64.
5.64.
So that's alive.
Jack can zoom in for the money shot.
Oh crap.
Okay, so have you put the amperage at max?
I put the amperage up to max, so let's get the focus first.
Okay, yeah, I'm
Okay.
waiting.
Burn it.
Finish.
Okay, it will die instantly, practically.
Oh, look, it ticked off again, and that was smoked. Oh, it died.
So as long as the casing survives, I think it's fine. It will show fine. But yeah. The rating, like you said, is for keeping the characteristics.
Yeah.
Yeah.
10 amps was too much for it.
Yeah, I know.
Let's put it under the
Right,
microscope. Let's have,
Yeah, no,
give it-
we have a nice internal view.
Oh, okay.
Oh.
It's split exactly in the middle.
Okay.
Okay,
So second video source that.
okay, so I'm going to bend one up. Give me a sec.
I got some tools if you want.
Oh, that's fine. I have strong nails. There we go. Okay, so I'll put one laying down and the other one up like this. There we go. So it's like a socket and what? It's like a socket. A
This
socket.
is probably the PN.
Yeah.
bridge. Probably.
So what's,
PN
so what's
junction.
inside this bit though? If we bend this one.
The PN junction. Yeah, one is outwards and one is inwards. So
Oh no! Isn't that like a little silicone die on the bit that I've got? This
yeah,
one?
exactly. That's the NPN
Can you
junction.
guys go closer?
Yeah, can you hold this? Can
Yeah,
and I'll
yeah.
get closer.
Yeah, sure. I'll hold both.
let me just alter the one. Give me a moment. I'll just alter the position of this thing.
I just have to move the phone so I
For the next live stream, guys, we'll actually have the Zoom working on this properly. But for now, there.
Okay. Yes. So that's the junction. Yeah, you are right.
This is probably the junction, yeah.
Yeah, that's
I
the
guess.
junction between the sandwich of different.
There. No, I've got
materials.
it.
Or the doped materials.
Yeah.
Oh, interesting. Can we get even closer to this? Let's see. Can you zoom in there? Want to try to keep it steady? Oh yeah.
Oh, better.
Yeah. So that's silicone. Okay. Yeah. Cool. I haven't seen inside one of these.
No, never looked inside. the
No.
And the other one should have a similar pattern on it because it got ripped off. So let's see.
Yeah, Rory, 1.1 amp will probably last forever because these are rated for 1 amp. 700.
Oh yeah. Oh, look
Yeah,
at that.
there's the silicone. Yeah. So this is the other part of the sandwich. So this is a NPN, right? No, sorry.
Is it a PN
This is
junction?
the
PN.
cathode. You're holding the cathode.
Yeah, the cathode. There we go.
This end is the cathode.
Wrong wording, right idea. Yeah. Okay, so it's like encased in another metal, and the
There.
the
That's
Oh,
better.
nice.
yes, yeah, you can see that silicone.
Hang on, let me get rid of this menu off the screen that
The
people can
menu
see.
there.
Now we can see.
So that's silicone. It's very clear now. So it's encased in some kind of metal around it, or is that metal even? It looks plasticky.
Looks plasticky to me as well.
Yeah. So
And what's the other side look like? Now we've got the
Yeah.
lighting on.
let's get. You have to be very steady with your hands. For this.
Oh.
Yeah, there we go.
Oh, is that where it's failed? Like
Yeah.
the little...
Yeah, exactly. That's the sandwich.
like the bottom left-hand corner.
Yeah, it's started to melt.
Oh.
Looks like it started to melt there.
Yeah, but this side looks metal. The thing around. So it's encased in plastic and metal.
Huh? Well, there we go.
Now I'm curious how these are made.
Yeah.
I'm not going to trust any of those diodes. If anybody wants diodes for free, just let me know. I'll put them in the post to you. You pay the postage.
The postage is so much from Canarias. It's insane.
Okay, so we've blown something up.
Yeah, we started good.
Did we learn something?
1.1 amp will probably last forever. You're right.
Yeah.
Well, we've proven that we can get 6.5 amps in, so it smoked and it still worked.
Yeah. So as long as it doesn't separate or the casing breaks,
Yeah.
it should work forever as long as you let it cool down.
Yeah. And the other thing you've noticed is that we could measure across the diode with about 6 amps, 1.2 volts,
Yeah, that's the forward bias voltage.
which has gone up
Yeah, quite a lot.
quite a lot.
Yeah. So the temperature makes the forward bias voltage go up,
Increase, it would seem.
but it made yeah, but the actual junction went down in value to 0.4.
Why did you say the junction went down?
It showed 0.4
The
instead.
resistance.
Yeah, the
the
resistance.
On the meter.
Yeah, so
Yeah.
why did the voltage go up?
Yeah, so why did the voltage across the diode go up?
When the resistance...
Because you were passing a higher current through it at that time.
Oh yeah, and the resistance went down.
On the diode mode, you're passing a milliamp or something.
Yeah, exactly. Okay, yeah, fine.
Richard, do you lift one leg of the 3 diodes in the HK speaker system and put a positive voltage on to see if it goes out of it? No, not yet, but tomorrow I'm doing a PCB way. I have an obligation to do a PCB way before 26th of the month, and after that I'm back on the HK. So next week we'll have another look at that.
I've been on sick leave from both work
It's an interesting video.
and YouTube, so I have to make one as well.
The other thing, Josh, and to everybody else, I'm actually learning from that HK. I mean, I know the techniques, but I don't know what the result's going to be.
Yeah, no, they can get so advanced.
But yeah, so yes, we'll try that. The other thing, Judge, about those 3 diodes, so he's referring to when I was actually testing a amplified Class D amplifier. It's a bit complicated if you haven't seen the video, but basically I've got 3 diodes and they're all conducting.
Okay.
So each one, as far as I can see, monitors via an op amp some sort of condition. And I would suggest that the idea is that any one of these 3 sources can put the speaker into protect mode. if this happens or this happens or this happens.
So any of the three will activate.
Any of the three will activate protect mode.
Okay.
But the way it is at the moment, from what I can see, there's some sort of fault in this circuit, is that any one of them that was not active would activate. Sorry, at the moment protect mode's on.
Yeah.
With all three active, and if you take any one off, then protect mode goes off, even though the other two are still active.
So
it's like an OR. So effectively, you should have, no matter what the signal is or the voltage is between protect and not, the situation should be that any one can put a voltage on to put it into protect mode.
So that doesn't matter which one, just
yeah.
one of them.
Whereas at the moment, it doesn't matter which one you put a voltage on. That would actually take it off protect mode, I think, because protect mode LED.
Oh yeah, right.
But I'm gonna. This is going to get investigated in the next.
Yeah,
part.
no, it's
The logic is back to front to me.
Exactly, it's back in front of exactly what you.
I think what's supposed to
Sounds
happen.
like an OR gate with diodes.
Yeah, an OR gate with diodes. That's exactly what it's an OR gate with diodes coming from op amps, and they're all going down to like minus 14.8, which is the negative voltage rail for it's plus or minus 15 on op amps. It's an amplifier, a mixer amplifier. So yeah.
Yeah.
So yeah. Anyway, guys, we're looking at that a bit further for sure. Try 1.1 amp. Yeah,
no,
we've talked.
It
about.
will never die. Never.
So Detlef, what happened to you last week when you ordered some processors, some microcontrollers?
You remember, you guys remember the Mr. Bleep thing, right? You remember the Mr. Bleep thing? I thought, okay, I need a ATtiny controller for that, and I thought I didn't have any ATtinys in SMPS 9 around. I had. I was simply looking in the wrong place.
Of course.
So we ordered some from China. But Uncle
Carlos.
That wasn't me.
Lucky me.
It was your fluid. It's your fluids all over the desk.
I didn't throw up this time.
Sorry, we need to clean this up first.
Give a sec. That left.
I made a mess.
Didn't hold the can correctly. So
everything smells like this. What
are
you drinking?
It's some sort of, God knows, it's one of these.
it's from
like rotten gummy bears.
Kong Strong.
Rotten gummy bears.
Oh, that smells.
Yeah, it's pure sugar.
That smells seriously like it wants some Jägermeister in it.
Drop it over there into the.
And it tastes really good with alcohol.
It tastes great with Jägermeister in it.
Yeah, it tastes really good with in anything bitter or sour.
Yeah.
Really
so we ordered some from China and they arrived.
Oh yes, your ATtinys.
ATtinys, a bunch of them, and
you can put them in the market.
Okay.
Yeah,
let me move this out of harm's
please
way.
get it
over here.
Yeah, my ATtinys, and
let me get the microscope back on for you.
the important word is written in green. Fake.
Okay, let's put this.
What, they said fake on when they arrived?
No, no, they usually don't.
Because that would be a bit of a clue, the important word fake written on them.
Yeah.
I think we need to go up higher than that.
Yeah, these are quite big in
There.
comparison. There we go. So they look nicely packaged.
Well, let's take one out of the package and let's have one.
There are a few here already.
Well, grab a fresh one.
Oh, a fresh one.
The fresh one.
So we know this is out of the package.
Okay, so let's
Look, maybe
I'm even doing it on camera. Could we?
We
Do you have the mark? Yeah,
do
thanks.
please a mark with
No,
the,
I just adjust the lighting on here. This would come nicely anyway.
Okay. So does that say ATtiny? Do you have a permanent marker that usually? Okay, so let's try this with
Hola, Cliff.
this marker.
Gracias, my friend.
I'm going to try something. Sorry, guys. I'm just going to rub that in.
I thought you want to mark it so we have an idea that.
Yeah, no, I'm
it's
going to
a
try
fake one.
something else.
I-
Rub it into the actual marking so it shows up better.
So, Dad, how do you know that these ATtinys are fake?
I tried to program them.
And what happened?
It won't program them, and I can show
What,
you guys.
it just doesn't appear?
Okay, so let's see.
Yeah,
Can
no,
we read
the,
this
the
better?
programmer sees that there's a chip, but it tells me no, I can't
Okay,
do
let
anything.
me
without-
try this like this.
Yeah, angle it because of the light. Yeah.
So-
Okay, that helped actually.
It's upside down.
Yeah, it did help a little bit. But
I should put this on camera. With
Oh, look, it's dead now. It's lying on its back with its legs in the air.
yeah, okay.
That's usually a sign of something being dead. Okay, so he says Tiny 85 Atmel 20U.
Which is fine.
Yeah,
20
that's,
megahertz, ATtiny, yeah.
Yeah,
Tiny 85. So that's what they say on them.
22, 20th week of 23. So
So
markings are fine.
Yeah, it looks original.
That's what I thought.
So-
put it on its back. Does it have any markings?
Have we got an original one we can compare it with? Have we got
Yeah.
a working one we can compare it
The
with?
USB is not there.
Oh, there is PC.
No, that not there either.
Oh, take this.
There.
Well, Det's going to set up his program and show you guys what happens. And then,
You had one on there.
yeah, we get an original. Well, we say original, we get one that works. And we'll look at the difference.
Oh, it wasn't
Can you mark them in, say, green, so we know this is a
real one.
real one?
Or how about just not marked?
I'm not more than
Marked in green, go for green.
Yeah.
You know, this is like, do you wear contact lenses? I wear contacts sometimes. And you go to like the optician, they give you the contact lenses and 2 boxes. And they write R on one and L on the other.
Yeah.
Doesn't help really because
And I thought, well, if you've written R on one, where the fuck do you think I'm going to put the other one? I mean, pardon my friend. I mean, why do you have to write L on the other one? It's like...
Okay, so we have them side by side. Here.
It's like, oh, well, this is the right. God, what do I do this other one here? So I've put L on it. So that's a one that works. At
Yeah.
Mel 20U, Tiny 85.
Okay, so it looks, the font looks a bit different.
well,
Fine.
that doesn't,
And this is
that
one
doesn't
that-
mean anything.
And this is
Yeah.
one that, oops.
Yeah, it's just a new other factory, obviously. But it does. Oh, wait, is the text engraved on the other one?
Can you do it, it's easier if you do it from your
Yeah.
actually goes on there.
So I think this is just flat print. Yeah, it is.
That's like flat print, yes, that's like flat print.
And this is engraved.
Oh, so in fact, actually, the flat print probably looks like a fake.
Yeah.
I think the flat print is from Mauser or DigiKey.
Okay. And this one,
Oh, crap. Sorry, it's jumping around.
playing Tiddlywink. Oh yeah, this is engraved.
Yeah, this is engraved. Okay, so this had been ground down and
Isn't this
reapplied.
way more expensive to
Yeah.
No,
to
no,
engrave?
not
Engraved rather than print.
not if they use a galvanic laser. They can do 1 million an hour.
Things I don't know anything about.
No.
A galvanic laser is
I know what a galvanic laser is.
stationary
Dutch,
laser
I'm totally with you.
with the mirror.
With a mirror.
Yeah,
I think they call them disco lasers normally.
yeah. You
I
can actually.
didn't expect this because this is a cheap chip. I thought this won't do anything, and it won't be feasible to do a fake of these.
Okay, well, let's try them.
We can remove the casing of one of these.
We've talked about that, but I thought before we do that, guys,
Let's try to program one.
hey, let's try to program
Get
one,
this into
and
the
then
adapter there.
Okay,
And
the
then-
fake one.
I need to show you what Carlos is doing now, right?
Yeah.
Oh,
and then
kill everything.
while these are doing the cameras, then guys, the other thing I thought we could do is, you
Number
know,
one is where I don't see the freaking point.
That's what I meant with markings, because I normally paint my chip where the where the dot is with some.
Okay, to help yourself. Okay.
Yeah.
There we go. Ah.
no, you haven't done it right.
No.
You,
He jumped out. Yeah, I have to push down.
you have to push down.
Yeah, no. I let it go way too early.
Yeah.
There we go.
So while Carlos is doing this, what I thought is that
Okay.
we'll see whether we can prove or see any difference. You know, you guys see me looking for diodes inside op amps to see if they are faulty or not faulty with a multimeter, as whether I can see any difference between the fake one and the real one.
Did I put it in upside down?
You did?
It smoked. So.
Okay, you killed.
Oh, he's killed it.
Okay, this is not a fake one. This is simply a broken by Carlos one.
Yeah,
You plugged it in back to front.
I did right. Wait, number one is up here, right?
No.
No, number one is not.
Number one is at the other end.
Then it's the wrong way around. of
Yeah,
course.
this one is dead.
This one is dead. We know this one is
I
dead.
killed
right?
this one.
Did you get it on camera?
No, I don't think
Oh.
so. I took it out way too fast. I'm still recovering.
So is that one of the fake ones he's
Yeah.
fixed?
Don't worry. I won't.
Try another fake one.
Yeah, I took another fake one and put that pink
A
dot,
pink dot on it.
and this time where the freaking marking is because it's
Okay.
so small.
Yeah.
I can't.
That's what I thought when I saw those.
Yeah, and then we put this in the
Yeah.
adapter. You put the adapter in the program the right way around.
Yeah. So I was.
Chips on the other way.
Yeah.
You can do it. You can do it.
Yeah.
Don't get stressed. Don't get stressed.
No, I've been working with components a lot smaller than this at home, so I don't know why this is a problem. But the freaking keyboard keys I bought were.
Oh, you're assembling the keyboard?
Yes, and it's.
Shall we just check that in the right way around under the microscope?
Is this the right way around it? That like,
Yeah. It doesn't matter if you put it on top or at the bottom, but yeah. Go.
Yeah, no, I don't want to kill another one.
You've got the clamp the wrong way around.
Did you?
You've got the clamp sticking up, but it should be flat down when it's in.
Oh.
Interesting.
You put it in now.
It didn't work.
I didn't know this works.
It did.
Oh,
It
okay.
did
That's
work.
how it should be.
Yeah, it did work.
So this is connected to a little computer over here.
Okay. Arduino.
This should be easy because I simply want to let me check if I have anything right here. Tools.
Try a bit of focus.
Yeah,
Yeah, I'll hold your program.
Okay, thank you. The thing is trying to do an update, and it's doing this for an hour now. So I really hope that I can show you guys something. Because, oh yeah, there was some response. Yeah, it's set on ATtiny, no bootloader, blah, 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 blah. The programmer is an Arduino's ISP, so everything's fine.
Yeah, okay.
And I simply want to go for burn bootloader because this is all I want to do.
I think that Carl said the burning better.
Yeah.
And it should be done by now. This should be done like
Instantly. That. But it says burning bootloader, I/O board.
Yep. This will take
a minute.
Take a minute, okay?
Mm-hmm.
What happens?
Nothing.
It just stays there forever, right?
Yeah.
Whereas we could try a good one just to prove what happens.
I had a similar problem with the STM32s.
Carther, hey my friend.
With the fake ones.
Mm.
They updated the drivers for the Arduino packages, and they don't work anymore.
No, I know that this works.
Yeah.
And there's my error burning bootloader.
Yep.
Okay, so disconnected off the thing first. So.
Double check connections, blah, 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 trying again. And we're putting in a known good from my stash.
Yes, this the right way around.
Oh, sorry for the out of focus thing here.
Yeah, sorry.
Trying to concentrate on everything at the same time.
There we go.
Okay.
And then
the right way round.
yes.
Because you burnt the bootloader quite nice on that first one, didn't you?
Oh yeah.
This bootloader is burned.
This bootloader was burnt. Smoke came out of it.
Literally
okay,
burnt.
let me try if I can
Okay, let's try again.
Okay.
Okay, so give it.
Oh, wait. Look at this. Look at this.
So this is a good one.
Yeah.
Burn bootloader. Plop. Burning bootloader.
Running bootloader.
And it's done.
Done burning bootloader. This is how it should be.
Yeah. Okay, so why don't these work?
Well, can I try the first thing, which is my method I use for testing op amps, where I want to see what the resistance in diode mode, what I see on this chip.
Yeah, that sounds like a good idea.
And then compare it with a good one.
Okay, I'll remove your chip and put it in a safe place.
So this is a bad one, yeah?
They are so expensive.
Okay.
Not at all sarcastic. Okay, we'll need this in a few minutes to compare.
We do.
So if we can get the PC2 on screen,
PC2 is on.
and then if you can you get an inset or do something with the multimeter?
Oh man.
Overhead cam at the same time.
Can we do anything so we can see the multimeter?
Oh, I see.
Or the handheld, maybe.
Handheld is handheld. Simply handheld. Let me add a video source here.
Yeah, and you can add one existing one. Sorry guys, OBS stuff.
Video capture
we
device.
haven't tried this before.
Handheld.
Yeah, it should work fine. And then you just shrink it.
Okay, great. And then we get the multimeter.
Yeah.
Which will put onto its stand, if you like. Try that.
Yep. And I'll try to keep it in shot. Wait.
Yeah, okay.
There we go.
And we're in diode mode. No, we're in ohms range, so...
Yeah.
We're in diode mode. Detlef, which is the ground pin on the processor?
Oh, wait. I'll get you a data sheet, I think. Because I don't know. I don't know those by heart.
Sorry if you're getting seasick over there. I'm just going to try to use the...
Yeah, position this.
Yeah. Exactly. I need a source to
that'll
see.
come back in a minute.
Yeah. So I can focus it.
Ground is on pin 4.
Yeah.
Okay, fine.
Ground is 4, 8 is 5 volts.
Okay, fine.
VCC.
Ground is 4. Okay. So.
Oh, it was kind of.
Yeah, we have it.
Yeah.
Right, you might have to hold this thing down with the tweezers or something.
That's why I was prepping the camera.
In fact, actually, you know what? If we stick this thing back into the programmer,
I can hold it.
You can hold it. So we put the red lead on ground.
Yep. I'm holding quite hard, so hopefully it doesn't ping away.
Red, and then we check in reverse diode mode. 629. Can you make a note after this, please?
Okay,
6
wait,
to
wait,
9.
wait, 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 wait,
From
wait.
ground to pin 1.
Pin 1.
Wait. I'm not ready for anything here.
I sprung it on you with a piece of paper and a book would do.
Oh, not that plus we do. Okay, tell me which pins to which
Yeah,
pins to
1 and 4.
1
1 to 4?
Yeah.
is
0.628.
okay.
Next.
Two-
0.62.
Where are you going for this?
And you-
2 to 4.
And the guys can see
Yeah.
this, yeah?
Yeah, they can see that.
0. Point what?
0.62.
Everything's to 4. Don't worry about what the rules.
0.62.
Right, they're all going to 4. 4 is a reference.
0.61.
Pin 3.
So 0.62.
That's 0.6.
This will be a diode.
Well, they should all probably. So I'm reading the reverse direction.
Yeah.
So what's
That's
Yeah, same. This is
Same.
5.
that? That's 5.
That's 5, yeah. 5 to 4.
Mhm.
Okay, and then 6
Exactly the same.
I
Okay.
expected that.
and 7. Sorry, no.
Oh, it's pinged away. Okay.
Okay, I go again.
Yeah.
So red lead to 4, which is ground. 7.
Exactly the same.
0.6.
Yeah.
And the last one is VCC.
0.52.
0.52.
Another diode, okay.
So is this a diode package rebranded?
No, I would expect these to read like diodes in this direction because I'm in the reverse
But
direction.
is the,
So these are protection diodes to stop the
Yeah.
inputs going
Ah.
below.
But will the original one have the same values?
Did you have the right camera on then? Did the guy see it?
Now I have the right camera.
It
I
is-
probably saw the voltmeter.
Oh, okay.
Okay.
You didn't see anything? Guys? Probably not.
A piece of paper with a pen would have done very good.
Yeah.
Right, let's try a good one.
Yeah, okay. So I'll try to hold it for you.
Right, so Jack can read out the values that they should be.
Yeah.
Turn it the way around. So
Or it shouldn't be.
I guess they will be the same.
Yeah, it should be.
I want to see if this reads the same as the other one. Well, you
Yeah.
get upside down, it's a bit awkward.
Oh, sorry.
When I say upside down, I meant the wrong way round. Right, we're in.
Yeah. Okay.
So
4.
red to 4 again, 1. What do we read?
Same.
0.6.
Is that the same as on the other one?
Yeah.
Yeah. Go for
Pin,
it. This will all be 0.6.
pin 2.
I'm pretty sure that will all
Same.
be 0.6.
617. Pin 3.
Same.
615. Yeah?
VCC is the one I'm not sure. It
What
will
else do we?
show the
Pin
same.
5.
Same.
618. That, yeah? They're not the same as the other chip.
Let's see.
The intolerances.
Yeah, exactly.
The input outputs.
619.
Yeah, 6.19. Yeah. VCC is the only one.
619.
I'm not sure it will show the same.
Again?
Yeah,
On
same.
7. And VCC.
Okay.
519.
Actually, it shows exactly the same.
Yeah.
So there is no actual discernible.
There's no discernible difference between the two chips.
Or to know in advance that they
Could
are
be that this
corrupt.
is an 80. This is not an ATtiny 85, but a say 4.3 or something. This has less memory and cost maybe a cent less.
Well, what it isn't is like an op amp, because on an op
Yeah.
amp, dual op amp, the outputs read considerably lower than the inputs, but they still read like diodes.
Have you tried different?
No, I didn't want to go through all the list and
No.
try. Maybe this is this one, maybe this is this one. No.
No.
So is there any way to find out what that chip really is? Well, this is a good
Can you
one.
read it off?
This is a good one.
There's maybe a way to because the protocol is maybe there. You know what?
Yeah, it should have a initial bootloader, right?
No, it doesn't. This is a naked. These are naked chips. They don't come with a bootloader.
No, but not a bootloader, but something in it.
Is that the
It
one that-
identifies itself.
No. Well, if you go in programming mode, they should identify them as I'm an ATtiny 85
Yeah.
because you can't program them if they don't do that.
Is this the one that you
exactly.
burnt? It was over there. Is this the one you burnt?
Yeah.
What's this one reading the same test?
Okay, that
Oh.
one is going to.
Well, does this one read on the same test? This is the one that Carlos had smoke coming out of.
Sorry, guys. I threw off. Okay. Yep.
Okay. So this is the one that smoke came out of, yeah?
Yep. I'm holding it. Multitasking. Trying not to touch the
Okay.
camera. Yep. That's fine.
Mm-hmm.
That's fine.
Okay, this survived.
If this
That's
is
fine.
if it is the one that he burns, I don't know if it is.
It is 100% because I painted it and I smeared it all over the place. It's going to pink. Oh,
And then it's gone.
yeah. I felt it slip.
Upside down.
Yeah, I'm working on it. It has some flux, this pair of tweezers, so it sticks
Okay.
to one of the legs. There we go.
Well, I thought that would help. Okay. So VCC.
VCC is probably the one that's gone if something's died. Actually, that seems fine. Next. Yep, fine. Fine. What the hell?
What the hell? So
So it smoked, but it survived?
I wouldn't trust this.
No,
Could
of
be
course,
that the
of course
diode
not.
survived, but the
what's
core
it
is
reading?
simply
What's it
gone.
reading in the forward direction with the black to the ground, which should be, yeah.
Okay. Yeah.
So I think these would normally read open, pretty much.
Yeah, it should, right? Oh, they don't. Okay, yeah, that will read open.
Yeah, these should read pretty much
Yeah.
open in this direction.
Yeah. Oh. There was a value on VCC that should be there, right? Yeah.
217, climbing up.
Yeah, so
Interesting.
it's charging something.
2.3.
Okay.
Well, I know it's charged inside the chip. Try a good one.
Well, you got 3 volts on there, right?
Yeah.
Yeah.
This is enough to start the chip.
Oh.
Uh-huh.
Well, that was the dead one that burnt. Try this one.
Yeah.
So-
So this is the real one. Oh, okay, give me a sec.
You got all those.
Yeah.
The embedded hobbyist. Yeah, I
Okay.
thought the same way, but I was too lazy. I was
So
really
this.
too lazy.
So what's this reading?
Same, and it's
Much lower.
Oh.
2 point. Oh yeah, right. Yeah.
The other one was
Well,
reading 2.3.
And climbing.
You killed this one. The
The,
other one was
the
a killed
other
one.
one was a killed
Yeah,
one.
try one of the fake ones and let's
Okay,
see
try
what
a
they-
fake one.
We had a fake one open. Not this one. This one is dead. Let's put this away.
Where we know where
Give me
it
that.
is. And where's the
Give me
fake
that.
one?
Give me the fake
Yeah.
one.
That's fake
Yeah.
and dead.
Fake and dead. And where's the fake
Yeah,
one?
fake one goes into the empty Coke bottle.
I don't know. Where did that go?
You put a purple dot on it.
Yeah.
Now the Coke has a CPU in it.
Okay.
Okay. Those are deadlifts markings. Did it fall?
Grab a new one.
Well, grab a new one.
The
Yeah.
fake ones are fake anyways.
Yeah, you can't even program them. So.
Yeah.
So the fake dead one went to 2.3. That was 1.2.
Yeah.
And this is another fake one.
Yeah, but this one is not dead.
It's not dead.
Well, it shouldn't be.
Well, it hasn't been Carlos just yet. Upside down again. Okay. So let's have a look. So in the normal direction, then black lead to the ground.
Yeah. Should show open on all the pins except for.
What's this read?
2.2.
Oh, so they read diff and climbing
and
up.
climbing, yeah.
You've
Okay,
lost that.
so even if the other one was
So-
dead, it's behaving the same.
Yeah, that. And then we take a good one
Yeah. Okay.
again,
Interesting. We're getting somewhere.
and we read on the VCC
1.3
1.3
and stay stable.
and stay stable.
So whatever chip that has the same voltage inputs.
Embedded hobbyist already. All the Atman microcontrollers have 3-byte signature code when it identifies the device. This code
Yeah.
can be read in both serial and high voltage programming mode.
Cool.
Yeah.
Yeah, good idea, and we can read it off as an experiment in the next one
Okay.
to see exactly what it is.
Okay, so we'll see those again. Yeah? Is that what we're saying?
I was simply going for it. Try these now. And
Oh,
that's
try it.
Yeah, okay.
Go for it, Dad.
Do you know how to read it off?
No, I've no idea. I'll find it out. Can you give me the fake one of the fake ones?
Here, there's a live fake.
Yeah, fake.
Why?
Here's
Fake.
or living fake. It's alive.
It's living evidence of the fakeness.
Yeah, pretty much, and that's a real one. So that's already programmed.
Oh, you could fake the signature too. They probably wouldn't have done this because if they faked this, it would probably say, okay, I can now do the bootloader thing.
It will probably say programming done even, but not do anything instead.
Anybody want a beer?
No,
Yeah, please.
I have my
And you guys want a beer?
energy drink.
Excuse me, I still have a cough, by the way.
Yeah, we all had some bit Kalima fever last week.
Yeah, it was very sandy and nasty last week, and this week it's rain in
Yeah,
Canada.
it's actually raining.
Only
this
for a
time.
few days.
Yeah, it never lasts.
So this is the new term. I've Carlosed my chip.
We had the yellow,
We need a t-shirt.
yellow weather warning for snow. No, we had the yellow weather warning for rain.
Yeah.
Oh yeah.
Oh yeah, somebody commented on one of my videos. I mentioned about the weather warning here.
Yeah.
And how did he put it? He says, we had a yellow snow warning the other week.
Yeah.
Think about it, a yellow snow warning. Watch out, there's yellow snow coming.
They never eat the yellow snow.
Never.
Never eat the yellow snow.
Actually, don't eat any snow. You're gonna find outside.
Yeah, you can show one or two of these.
Oh yeah.
What do you reckon, guys?
So we got some t-shirts for deadlift order.
I thought these guys need something nerdier.
Yeah.
Well, the one I really like, this is my favourite, but in the wrong size. This one,
They fit me, so I got 3 t-shirts.
Schrodinger is dead. Who gets that? Well, you guys must get this.
Yeah.
Yeah, they do.
Dead.
Yeah.
They do.
And there is
Come
no
on.
way
Yeah.
none of them knows
Yeah.
what Schrodinger is.
All the nerds are outside.
Yeah.
Yeah.
Well, the cat obviously has got him now.
Yeah, the cat killed him.
You're not sticking me in a box.
I also this one is from the same bag. No internet and the dyno you get from Google.
Oh yeah.
I play that many a time. When internet dies, you don't have anything to do.
No internet.
I only have 500 consoles at home. Cheers.
Dorado Especial.
Yeah.
This is a Tenerife beer.
Yeah.
Tenerife.
You see the tail there on there.
Mount Teedy.
Yeah, that I can't believe you. I don't know how many chips I've killed. I always
Cheers, guys.
order 5 or 6 extras.
Salute.
Salute, indeed.
Yeah.
Do you have anybody here from Finland?
Oh, and I read this is the happiest county in the world.
Get
today.
pissed.
Yeah, get pissed. In Finland, get pissed.
Get pissed, guys.
Get pissed. That's what they say. Get pissed.
Get pissed. I don't think it means the same
No.
as in English.
And it's not
Probably
actually
not.
get. It's get pissed.
Yeah.
Get pissed.
They say it quick enough and it sounds like
The
right.
Finnish people are the happiest people on this planet. There was a thing where they do a survey and Finnish are the
If
happiest.
you're drunk
Probably.
24/7.
Germany, by the way, is on was place 26 or something. So
Sweden has a very high suicide rate, so I don't think
no,
that's...
you're not late. We just had some explosions.
Yeah.
Everything's
We
fine.
just burnt some things. Yeah.
No worries, Paul.
Dad, would it be possible to make an intelligent timer for charging laptops with a barrel plug so we would discard it and recharge to protect the laptop that's plugged in all the time?
You mean so it
Oh.
doesn't charge it, trickle charge it all the time?
Continuously.
How would we do that?
There actually exists USB plugs that do that already.
No,
They
this is, we probably have to
A
do this
barrel jack.
on mains.
yeah, and,
Or on the 20 volt line.
what's it called? I don't want to making more money, but Linus Tech Tips last Microtex things, cheap stuff from AliExpress had one of those wall warts. That
I saw this.
timer thingy.
Yeah, the timer thing.
It's
But this
exactly for
isn't,
that.
it isn't automatic.
It-
This was for trickle charging. If you have a device that stays in a shell for say
Yeah.
years and you want to charge it every 3 months or something.
Yeah, exactly. You could put that timer
Mm-hmm.
on and tell it charge it maximum that amount of time.
Judge, give me something more. How would you charge this? Because this is probably a thing for a micro where you measure the current. You can measure the current in the 20 volt line, so you don't have to five around with
Yeah.
the mains voltage.
Yeah. Okay. Yeah. That sounds about.
And if the current drops to level where the thing is going, okay, my battery is full, you can switch it off for say, which is
An hour or so.
No, it's
No
it's
more
short.
a day.
Well, no, it depends if it's still running or not.
It depends on. Oh,
Is
yeah,
it still
right.
running? Give us something
If
more
it's
to
still
work with,
running,
please.
If it's still running, yeah, an hour would be pretty okay. If it's not running and it's not actually consuming energy, A day is pretty good.
Yeah, I'd say 24 hours.
Yeah.
Yeah. If it reaches a stable, I don't charge this anymore. Yeah, you need to measure the current. There are some intelligent I2C sensors that can measure currents up to some crazy amounts. That could work for that. This would probably be my idea for this.
Yeah. You're not far off with the
Yeah,
mark.
a little micro, we don't need anything fancy here.
No, not really. It just shuts off.
Wouldn't you be better using the PD to barrel adapter and then control with the PD thing to switch the power on or not?
Yeah, the PD is mainly for getting the 20 volts there, but yes, I keep it running, keep the laptop running for 24/7. Okay, so you want to have this. This is a different approach.
An hour
Yeah.
would be the best. So,
Yeah,
it
so you want to keep a constant on, off, and
so it doesn't hit it directly when it loses, let's say, 0.01%. It waits a while until it gets to like an hour. A laptop has about 3 hours runtime, depends on the laptops. Let's say 7 at the maximum. If you lose a third of your charge, it will start charging in a high capacity charge instead of the low trickle thingy. So yeah, I would say an hour would be good enough for most laptops.
yeah. It shouldn't be too hard.
No, it's really easy to make. We could whip up a prototype PCB.
I have something we can play with.
Oh,
Do you want a new hole in your?
Yeah, look. Look.
Yeah. Oh, I used these on my
Put them on the microscope.
switching cameras.
yeah,
Microscope.
microscope. It will be better. And I'll raise it up. Oh,
No, just for the, oh yeah, yeah. You have to raise it from the back.
yeah, exactly what I was thinking. The arm was really nice for this.
Yeah, they're sending me a flexible arm for this. And they might go up to my bench. Okay, so guys, Detlef sent me these, or he gave me some of these.
Yeah, they're really, really handy.
So these are direct replacements for 7805.
Yeah, it's a switch mode power supply.
It's a switch mode power supply on a little PCB, physically basically the same size as a 7805.
And the same pinout.
And the same pinout.
Yeah, and
So-
they fit really nicely.
And
Yeah.
from the datasheet, it should be supported for 3 amps.
Yeah.
So what I was interested to see is whether we could try these. If I get, like, we got the bench power supply, so we stick some voltage in, and we take like a power resistor, put a load on, say an amp,
Yeah.
and let's see which gets the hottest.
Yeah, I can already tell you. I did the same test with my ZX. I actually replaced the 7805 because it got like 80 or 90 degrees. And I replaced it with one of these, and it actually doesn't even register for my camera.
So I don't know. So, are you guys interested in seeing that, or the other thing we can play with?
So there is a video on my channel if you want to go watch faffing around with this thing.
The other thing we can play with is maybe is these.
Oh, we can show it live now if there is interest.
If any interest, we can compare the two.
Oh. Rechargeable 9 volts.
Oh, I was looking where they went, and I didn't.
You should have just asked me. I knew where they
Yeah,
were.
I couldn't remember they were left in the shop.
Holy crap, they don't weigh anything. Okay, so lithium cells inside, the flat packs.
So you can charge them both at the same time.
Okay, I guess.
Very standard, yeah, totally standard for USB.
Yeah, no, do not plug this in anywhere else. Holy shit.
Really?
Probably in parallel, so.
Yeah, they
Oh
are.
my god.
Yeah, that's not a good idea.
So
but-
these are
okay, so
the
it has a
direct
light.
replacement PP3 9-volt batteries.
Yeah, so it has a light, so a charge light, I'm guessing. Okay.
Shall we get the USB analyzer?
Yeah, please.
Yep, that would be best. I don't think this works in PD, right? Shit. Wait.
Okay.
Now that I think about it, this is 5 volts, right?
Yeah. There's
has-
a step up in there.
Yeah, there has to be a step-up converter.
It must
instead of
not
battery.
step up converter. No, surely this just uses PD, doesn't it?
No, it
No.
Oh
doesn't.
no, because it's a normal.
No, it doesn't.
Because it's just not. It's not. Yeah, it's not USB-C.
No, so
So it must be 5 volts in.
and it steps it up inside, or there are multiple cells
Well,
that charge at
Well, I tell you what,
in parallel.
the USB analyzer will tell us.
Indeed, it will.
So we need to connect that to the output.
And this one goes here. right?
Into the power, but yeah.
Let's see.
Chris, I think this is the problem is there that they always put out 9 volts, so the step up will be running all time. I guess it would be the problem.
No, the USB thing will probably.
I don't think it's
no. No, this must be putting out 5 volts.
Yeah, it is.
What's it say on the screen? I can't read it from here. It says something.
Test.
Test? What?
Wait, what? No, tips. Sorry. Ready. Okay.
Right.
Okay, now it's doing something.
Yeah, so it's showing 5.1 volts. So yeah, it's normal USB voltage.
We got some focus.
Sorry.
Yeah. So 5.1, that's normal.
1.2 amps. Wow.
Yeah, so it's going there. It's not getting hot. So that's good.
Oh, you have both connected. So
Yeah.
this is 600
So
milliamps per
if
cell.
we do this, we'll half the amperage.
I don't know, that moves away at the same time.
Yeah, okay.
So you can't see it.
So,
Yeah,
okay, so I
600
removed one of the batteries.
600 milliamps per cell.
Yeah, about 600. And so if I hook it up again, yeah.
Yeah, 1.2.
Okay, so there are 2 ways these can work. Either it has a step-up converter inside.
Must it?
Sure it has.
No, it doesn't necessarily.
Well,
you could charge every cell individually at 3.3 with a 5 volt supply.
how many cells are in there?
In parallel, 3 probably.
Okay, so you charge all
Then
3.
it would be for 12 volts or something.
Yeah, but then you have the regulator.
Wow.
Mm,
Do they come apart?
Do we want to kill them?
You know that I need. You know that I need at least one, please.
Okay, so no, we don't want to kill. Well, I'll tell you what. Let's have see what
If
volts
we
is
want to
on
have the other one, we maybe kill one, but
No, we don't kill it.
No. I'm just going to check if it is possible. Yeah, it is possible. It has a seam here under the sticker.
Okay. Well, before you do anything with them, let's power them back up
Yeah,
and let's see what's on the terminals while they're charging. Do we have 9 volts coming out of them?
we should. That would be very useful for
In fact,
some
you
kind of
use that one as clean.
some kind
display.
of tools actually.
That's exactly what I'm thinking, to put into a multimeter or
And
whatever.
have
I
a constant
think
supply.
the standby isn't really great because I think it keeps the 9 volt step up running all the time. We can check it in a minute.
Yeah, we are. That's the idea, I think. Okay, so voltage.
Yeah, that's it. That's
The
easy.
negative is the big one, right?
I think so. Well, it'll just read minus or plus on the meter.
Oh yeah, no, it shows a plus here. Yeah.
9.47.
Okay.
So it is outputting.
What's on the other one that is not connected to the charger at the moment? Is there any charge in it?
Sorry, guys. Okay, yeah, I'm back. Yeah, let's see. There is 9.36.
Paul got the right question here. Does the output have noise?
This
This would be exactly my question.
Well, shall we charge them for 5 or 10 minutes and then have a look?
Yeah.
Yeah. So these ones. Let's see how do we switch. Okay, so the small replacement ones. I actually checked the noise level with the oscilloscope. Richard's mini.
This is the 7805 replacement.
Yeah, this is the 7805. It should have this similar technology inside the battery.
Yeah, it's a boost in there.
It's a boost. So these actually had less noise than the 7805.
No way.
Yeah, they did.
Really?
Did you check on the load?
Yes, I did.
Okay.
So that surprised me quite a lot.
I'd normally say a linear regulator is always the better
Yeah, no.
choice if you need to
It depends on the make. Because I had one linear regulator that had less.
Well, these are cheap. These are dirt cheap.
Yeah, these don't cost more than 50 cents each. These are super cheap,
Yeah.
and they're really reliable.
And they're
Can
available
you
as
please check what chip
7812
is on
and various
there?
other.
Can you please check what
Yeah.
chip
Yeah.
is on there?
And these 7805 replacements, I'm sure we would get like 7808 and 7809 and 7812, yeah?
Yeah, there are different ones, but they are kind of bulky, the other ones.
What, like the
Yeah,
7812
but
or
obvious.
7815?
I'm with you there. This
Yeah.
will be a single cell boost circuit in there.
Yeah.
And this is why they can't hold the charge because they're always standing at 9 volts out in the output.
Yeah. Yeah, exactly. They are pretty much killed. So I think I can get the markings a little more visible. They scratched them off, pretty much.
No, they didn't. Well, no, they did.
They did. But if we do this, give me a second.
Look at this. Now learn something from Carlos.
Yeah. So
Not only killing chips.
so if you do this, it looks
Sorry.
like it looks like you're destroying the chip, but you rub it off afterward with your finger, and it
Now
seeps
your big
in.
finger. I
It
see
zips
Now
in.
you have a big finger.
I see the logic in there.
Yeah,
What
but
do you do?
in some cases you can
Well,
see
it's better than
the
having a brown finger.
Indeed, yeah.
Yeah, I know. I would rather have that pink finger than a brown one.
No innuendo there. Oh, sorry, innuendo.
In your
Innuendo, yeah, innuendo.
in your endo.
Innuendo.
Okay, so this didn't work. So they
Then the
actually
steel catches on fast.
they scratched it off really deeply. Normally you can actually get the markings out again.
I bet this must be a really standard chip.
Do you have some IPA?
Ah,
Sometimes it
what,
seeps
what,
in.
IPA, you mean pale
Is
ale?
there an LM317 version? Yeah, can you put it down a little bit?
Oh,
Paul,
you
you see the two resistors on the left side now?
this one.
This is probably the feedback. And the feedback will tell you which is the output voltage. So
Yeah.
if
So
you want to change the output voltage, you simply change these resistors. If we know what chip this is, I could tell you how to do
yeah,
this.
so this chip takes up to 15 volts. I checked it on my own. The markings are not down. And you can set these resistors to different levels to get 3.3, 5, 9, and 12.
Can I suggest something,
Is
guys?
this just what I said?
Yep, pretty much. No,
Yeah.
but you can. I already checked the...
Can I suggest something, guys?
Yeah,
No, don't blow it up.
No, we probably don't need.
these are actually useful.
Right. We probably don't need to know what the chip is. All we need to know is what the voltage reference voltage is.
Yeah.
In the chip. Now it'll be internal, yeah. But I think we can say with pretty good certainty it's going to be 2.5 volts, like a TL431, or 1.25 volts. So if we take the ratio of those two resistors, if we read the values of the resistors, and we know the output is 5, right? If we divide, as a voltage divider, we can work out what the reference voltage is. That becomes to 1.25.
You can simply measure this.
We can simply measure. So what the two?
Give it 5 volt and see what's
Yeah,
going
Well,
on.
you don't. Yeah. Measurement. You don't. No, you don't need to do that. There's something called Ohm's law. So this is 5 volt output. Yeah.
Yeah.
Right. What the value of the two resistors?
Okay, the guys are interested. Now we have to check what the noise level on the 9 volt cells, what the
Holy crap!
Really?
In this one.
Oh,
They're getting
They're warm.
They're getting toasty.
Okay. Oh yeah. Let's put that on the thermal camera, guys. You've got to see this. So these are the batteries which we're charging.
well, it's 600 milliamps that they're putting in there.
Yeah, that's quite a lot actually.
Yeah.
Flare.
For a small camera, this is probably, maybe I should get this on different video here. Right?
Yeah, it takes a while to load the flare, so that's fine. You're not missing anything. That's what. Oh yeah, it has a hotspot.
Sorry for the focus. Now we have something.
Oh, how warm is that?
About 50.
55 degrees.
Wow. Okay, this is a lot.
Yeah, for a sealed can. Yeah, that's 55 and climbing actually. Okay.
Well, we'll let them charge.
So
We'll let them charge. Maybe they probably way down, so this is probably pulling in some major charge in there.
yeah, so it's at max heat, but still 50 degrees on this. It does.
Furnace fell asleep.
Yeah, I'm going to. There we go. Yeah, so it's
That's
pulling
still-
1.2 amps for both of them.
Yeah, so
1.26.
3 something.
Yeah.
615 milliamps.
The cables and stuff are not getting hot at least. So
Hey, Gordon.
actually, I wouldn't expect that as well. If you're getting hot cables from
We're
that.
trying to do the thing with the rechargeable 9 volt blocks and just realize this is getting pretty hot. And Rich over there has.
Okay, so let's go back to the 7805 analog.
Well, the first thing is, it looks to me like these two resistors. Does that pin, see where it says here, the end of this resistor? Is that connected? Is that connected to here? Can you just check with the multimeter?
Yep, sure.
I would guess this is connected because this would be feedback. So and
Yeah.
you see this.
This should be the feedback.
Between the two resistors is connected to pin 1.
And then the other end goes to ground.
Okay, so let's be.
Yeah, this is feedback. It's
Be-
classic feedback.
Yeah, it should be.
Yeah.
Okay, so where does pin
So from here.
from there to the resistor?
I'm really.
I think it's probably better with my meter than my meter leads.
Yeah, no, these suck.
Those suck, right? Let's use mine.
These suck. These are worse than mine, and my meter sucks.
Okay. Well, on the back it says 3.3, 5 or 12.
Oh, yes, there
Yeah.
you see. Yeah,
Yeah. So you can actually get 9 from
But
this
it's
thing as
not
well.
marked to tell you which one it is. That's good, isn't it?
yeah, perfect. Yeah,
for a bit.
Like you think it might be a blob in one of those squares.
that
Okay.
was too much work to get a workout
Okay.
there.
Right.
Marker.
So the first thing I want to know is the end of this resistor where it says in. That's 3.3, 33k, that one. Does that go to the out? Where it says X.
Yeah. So
Mhm.
it does.
So that's mostly that. And then the other end, does it go to ground? So the middle pin,
yeah.
not the junction, the other end of the other one.
Oh god damn it! There we
Does
go.
that go to the middle pin?
Yep.
Right, so the first thing we can say with this chip is the ground is on pin 7 and 8, which is kind of back to front from most chips, yeah?
Mm-hmm.
But we know those resistors, so the two resistors, they are marked 333,
333 and
which should be 33k.
03C.
C, so now we need to loop that one up. So
03C. What was
03 will give you a value and C will give you a multiplier.
Yeah. So
We can,
I can't really remember.
no, I have to look these up.
I
No, I tell you what, we could measure it. Just put the resistor onto resistor.
Oh, yeah. All right. What are we doing?
Let's see if we get a sensible measurement.
So we're on
Ohms range.
ohms range. Let's see if I can get my.
Can we get them up?
The C one is this one.
That one, what's it measure?
9 kilo ohms.
Let's just go up a bit.
It should be a 10 kilo ohm then.
We have to look this up, I think, because you're 1%.
03C.
Is it okay?
We could ask this Swarm Intelligence outside.
Yes, what it says 03C, it's a 1% resistor. Can you just look up the code, please? It's called the EIA resistor code.
Yeah.
EIA 96.
I looked them up on the internet because I can not for the life of me remember
Yeah.
the markings.
Nobody can.
Well, the other one is 33k. I think you can measure that one. The one that says 333.
Yeah, that should be at 33k, right?
I think.
Yeah. No.
Right, you mean?
Okay, so no, it's. I'm trying to get good contact here. Sorry. There we go. 36.
Yeah, well, that's a 33k.
Yeah.
Yeah,
So,
guys, who are you watching? What's the 03C savers looking it up? So look for EIA 96 resistor code, SMD.
yeah. Or resistor 03C.
Or resistor 03C, that'll do.
Yeah, that would be. That's what I usually search for.
Go on, I'll see if they can do it quicker than that.
Let me see if I can.
So resistor 03C. C is let's say 9. CA is 10. B C 13.
No, the C will actually give. Right, the 03,
it's zeros
the 03
behind.
tells you what the value is.
03C is 10.5K.
Thank you, Okay.
10.5 yeah, okay, yeah, that's
So let's get a bit of paper.
10.5k. Yeah, there are 3.
Pick a card, come up.
Okay, so let's think about
Sorry.
this.
No, right, we'll draw a bit of paper.
So it's a third.
It's a third, roughly.
Yeah, a little wonky.
Okay, so
3.5.
so we know the output is 5 volts.
Yeah.
So you have to divide it by that ratio. So what you do is, okay, you take the two values together. You take the 33k.
33,000. Yeah.
Yeah, plus
Mhm.
10.5 was it?
Yeah.
10,500.
Yeah. Give me a sec. Yep.
Right, equals
Equals 43.
43,500. Now you take 5 volts. So clear that.
Yeah.
Right, so you take your 5 volts divided by
Tony,
43,500.
hey my friend.
Yeah.
Okay, equals.
Yep.
And then you multiply it by one of the values. So multiply that by 10.5. That's what you get. Oh, sorry, 10,500.
Yeah, because I'm using whole number.
It gives you 1.206.
So
yeah?
that's the ratio.
That 1.2 is probably the reference voltage.
Yeah.
Okay?
Mhm.
So if you want to increase this, say, to 12 volts output, you have to use a lower value resistor than the 10.5 to give you the same voltage there when you got, say, 12 on the output.
Yeah, pretty much. So you lower the resistance.
You either lower the 10 or you increase the other one. I would lower the 10.
Yeah.
So it looks like these chips have a reference at 1.2 volts.
So what would 3.3 be?
Okay. Right. You know I said the reference is almost certainly 1.25?
Yeah.
It probably is. There's probably a slight error in the calculation.
Yeah, probably because the values are not
Yeah.
absolute either.
Yeah, so so once you know the voltage reference is 1.25,
You know how to.
if you want an output of say 12 volts, you have to use two resistors as a voltage divider that will give you the reference voltage at the junction when there's 12 volts coming in.
You know, one of the resistors is static.
Well, you can change either of them.
Yeah, you can, but it's easier to keep one static.
I would keep one static, so I would say that if the input is 12 volts, right, then you just work out what the junction is.
But this takes a lot of different voltages and makes it always.
Yeah, but if we change that resistor, the O3C, which is a 1% resistor, to a lower value, the output voltage will be higher.
Yeah. Okay. Yeah.
If we change to a higher value, the output voltage will be lower.
Yeah. Okay. I'm with you.
And you can actually work it out.
And Chris, you could use a potentiometer on this.
Yeah.
So.
Pretty much.
You can use a potentiometer and see what happens.
And have a variable supply.
And have a variable supply.
That's not a bad idea to put a micro pot like the ones I used in my
shall we try it?
RGB thingy.
Yeah. Well, let's try it.
Do you have one?
Okay, so we've got 33k plus it. It's about 50k.
No, but we can put the 10k.
Well, I was actually going to suggest it. Yeah, okay. Put a 10.
You can remove the 10k and try to get it down to 12.
And try to increase the output voltage to 5.
Yeah.
To 12. Yeah,
5 to 12. Yeah, exactly.
Yeah.
And we can measure it and see how much resistance we need for 12 volts.
Yeah. I hope it was easy.
I don't like math. And I program.
Okay.
That's why we don't like math, because computer was a math for us.
Yeah, no, but it's still in programming, when you do 3D stuff, you need to know a lot of math.
Yeah, there you go. Yes, try that. Okay, so well, if you guys want to chat a bit more, I'm going to solder a potentiometer across this, put it together on the breadboard, and let's see if we can make it.
You don't have any micro potential.
No, but
that's massive.
I have bits of wire.
Yeah, okay, that's fine.
Okay.
Here you go.
Thank you. I'll do it on my bench. Give me a few.
Oh yeah, this works better. Yeah.
I can see better.
Yeah.
Yeah, I feel you.
Okay, so me and Detlef are alone now. Yeah, he's going to use a pot, Rory.
Yeah. I'm trying to still find out if with the little
he took a pot that's bigger than the entire board, but that's fine.
We probably can find out what chips this is. Come on, let's try to do some research here.
Just go to AliExpress. And you will find the first picture with the chip name on.
This was the idea. Let me clean up my desk a bit here, because I'm sitting right.
I can actually do it for
anything here.
I think I can.
You can do this on this machine, so we can follow the. Good idea.
You can see what I'm doing, guys.
Yeah.
Okay, so I usually do research like this when I don't know what a chip is, because they forget to remove the markings on the promo pictures. Okay, AliExpress. Why does it have caps lock on? I don't know. $78.05. Okay.
I think you don't type anything.
Yeah, no, the stupid numlock is not working. 78.05.
Replacement.
Yeah.
Try this. I have no idea if this works.
No, I think I went with.
Okay.
Yeah, there they are. And the markings are there. Awesome. Okay, let's see if we can read them off. Is there a better? Yeah, there we go. There we go. Can I zoom in? Yes. There we go. 8XB07.
Wait. Again, please.
8X.
8X.
Yeah, B07. Am I reading this upside down? No, I'm not.
This isn't a
No.
marking.
Yeah, but it is. It's exactly what it says there.
Can you zoom in, please?
I'm trying to. There we go.
Oh, you can. Okay, perfect.
Yeah, okay. Yeah, 8X. AGC. Can you find something with that?
Try a different thing.
8X. What was it? 8X.
807.
B07.
B07. Okay.
I think it was. Okay, let me just check. Yeah, was a B. Yeah.
Oh, it's a B. Okay.
XB 07.
HX 1314 says Carson.
Yeah, that's probably right.
This sounds better. 1314G.
No, actually, there is a datasheet for
Okay, let's see. Let's
8X.
see. Let's see this.
There actually exists a datasheet, but I don't think it's the correct one, to be honest. No.
No, no.
That's a pressure valve.
Try the HX 1314G.
Yep. HX 1340G.
No, 1314.
14.
Yeah. You have to kill this all. Yeah, 14.
I won't be long, guys. You're getting there.
Yeah, no problems. Okay, so no, I have to go from outside.
Maybe want to press return.
Yeah.
I'll do that.
I just go for Google. There we go. Yeah.
Yeah.
And it has the. Okay, fine. There we go, and we have.
And look at this. This is a reference design. So,
Perfect.
yep, this is what you need.
Yep. I'm waiting for it to load up. There we go. There's the reference design. And the calculation for the resistance.
Yeah, this is what
Resistor range from 130K to 1.5 mega. Huh. So they're not using the recommended resistor range?
well, it's as long as it's somewhere in there, this is fine for them. But yeah, this is a bit low. You're right.
Was it cheaper with lower resistance? No, they're not cheaper.
Maybe this is what they're lying around. Yeah.
Yeah, but yeah, they recommend those ranges for a reason, right?
Yeah, this is normally for stability.
Yeah.
They say use this values. You stick with these values because you don't
Yeah,
want
and
to
the
mess
reference
around.
is 1.21, not 1.25. That's the normal.
It was closer to the 1.2 we worked out then.
Oh yeah,
I take it you guys have figured out what the chip is now.
yeah, we have it. Someone did. Carter.
Cartha did. Cartha won the prize.
That's nice to see that my calculation of what the reference would be was right though.
33 watching, man. Hey guys,
Nice.
it's like a good round here.
Someone new is here.
Good
Welcome.
crowd. Welcome, yeah.
Oh yeah, you don't see us. You only see the screen.
Oh yeah, wait. We can have a look.
Sorry guys.
Yeah.
Professional YouTubers. Okay, so the ZX I use on these chips actually works quite well on it, and it doesn't give any noisy picture or anything. It actually gives a clearer picture than the normal 7805.
Can you scroll up for see what the
The
quiescent
specs.
current or something?
93% efficiency. That's really good.
This is the switching mode regulator. Yeah.
It takes up to 30 volts. That's not bad.
Wow.
That's actually better than the 7805.
Wide input range 8 to 30 volts. Yeah, okay, this works.
So
Yeah,
the
100 kilohertz.
7805
Yeah, right.
takes up to 19 volts, I think.
Yeah.
So that's not bad.
Huh.
Programmable switching up to 500 kilohertz. That means it won't interfere with lighting and stuff.
Like this. Try it again.
I think that removes the like, if I'm not mistaken.
On that reference design, are pins 7 and 8 connected together?
They probably are. Yeah, they are ground.
Right.
Yep.
Both 7 and 8.
Yes, they are to ground.
In that case, then.
And for the reference design, they go for 470K to 150K as a reference. And I think they skipped the 200 picofarad. Yeah, that's its optional.
Can I ask how the viewer figured out what chip it was?
Cartha,
He
could you answer that?
probably put in this and got this. Because if you look this up, you get this.
Ah.
So he put in the name of the module, and he probably got the...
No, well done, Cartha.
Yeah, no, not bad. So in the reference design, there is a slight difference. They use another range of. They recommend another range.
The resistors.
Yeah. So from 130K to 1.5 mega ohm. So would that affect the peak,
No.
the spikes or anything?
I wouldn't have thought so. I mean,
Paul points out something really interesting. Can we get a close
Yeah,
up on
the tantalum is 16 volts. You are 100% right.
switch it to the microscope on the other computer?
yeah, well, I know how to do this.
Yeah. Yeah.
I'm sorry.
Because this is a stupid design choice.
Yeah, you should put in a 20 volts.
Maybe 20 volts. We can go up to 30.
Yeah, it can accept up to 30. Yeah.
Okay, let me just get it 1 moment.
But is that connected to the output only or the input?
No, you see the 16 volts over there. Oh, this could be the output.
It's connected to the output. It goes to the coil, so it must be going to the output. Where's the diode on the output?
There is none.
Maybe in the chip. It's probably in the chip. I guess it is.
Oh, the diode.
Haven't you? Oh yeah, right. 7 and 8 were together. Sorry, it was.
Yeah. So that's
I was going to.
This
blame
is
you.
why I asked you if the guy's not the best bit of soldering, but
No, that's fine.
works.
This is quite small work actually.
Yeah.
So it's missing the diode from the reference, and they screwed up with. Oh, this is the output. So
This is the output.
That could work. On the output, 16 volts is fine, and I guess the other thing here.
Is
Well,
this one is probably input. I guess.
I think they're. Oh, yes.
Of course, it's a ceramic, maybe 50 volts.
I'm not sure about that. They're not connected to each other.
No, this is fine. The output shouldn't be connected to the input.
Yeah, that would work. Yeah.
that would be a bad design choice. Yeah.
Can we go to the reference circuit again?
Yeah, sure.
It's that HD 1360 on the bottom.
Yeah, there is no diode on the output. It's DCT. Okay, right, fine.
Yeah, no, it's not there in the reference, so yeah.
This is not actually a buck converter at all. It's not a buck circuit. It's something different.
It looks like a linear regulator actually.
No, this is a switching mode.
Yeah, it is a switch.
Yeah, but
obviously
this is not a buck converter.
it's not wired the same. No.
Why not?
Or a synchronous converter, because you'd have a switch to the coil L.
Oh, yeah.
The switch end would go to fussing around, and there's a diode on the output.
The diode is in the chip.
Before the coil?
It should be after, right?
On the buck converter, yes.
Yeah.
This is something slightly. This is a different topology.
Just simply pull the stuff in there.
Yeah, he just pulsed it.
Yeah, this works. And
It works.
There's a MOSFET in the diode is in this direction. MOSFET.
Okay.
Is,
Oh yeah, right.
So in that case, then, if we plug
let's
plug it into our breadboard,
Yeah,
let's connect some power to it.
yeah.
I'll find you a resistor for the output, 10 ohms.
Yeah, that should be fine.
That's half an amp or a bit more, depending on what you want to take out of it.
It takes up to 3 amps out, so it's fine. Okay, so let's. How are these wired?
Judge, I don't think this is a charging one. For me, this is a simple. Well, if the guys scroll up, we can see what it's meant to be.
Yeah. Let's go for a reference. There we go.
Buck
Wide
converter.
range back converter. Yeah, it is a back converter.
Okay, so
So input.
I'm having a bad day now.
Input.
Input,
Ground. And then we need for measuring the output.
and then we want some more of those leads then.
One more.
They're probably not in there. If I can get them. Oh, we do. No, we don't.
No, we don't.
We have plenty. We have plenty more.
Yeah. we need 3. We need to measure the input output.
By the way, guys, I'm normally when I see designs like this, I normally go for the reference design if I need a voltage supply for something.
Yeah.
I normally check: do I have the parts available? If it's available, I'll simply steal the design because it's a proved design.
Out.
Yeah, that's fine.
And then we need some crocodile clip leads. So
And we need 5 volts in.
we don't want 5 volts. We want more.
Oh yeah, we need a lot more.
let's put 15 volts
Yeah, that should be fine.
on the power supply.
According to the data sheet, it takes up to 30
But
volts.
we could set 15 anyway, just
Yeah.
one chance. So
Let's.
that's fine. We don't need to worry about current limit.
No, because it will draw what it needs, pretty much.
So black is ground.
Yeah. So let's put these together.
Okay.
Ground is always in the middle on a 7805.
It certainly is. But hang on, we need to connect the load as well. So give me a moment.
It actually doesn't need a load to run
Well,
because it's a switch mode power
okay.
supply. So
right without a load.
it should give.
So yellow's your output.
But it's not
Oh yeah.
drawing anything.
Well, there's no outload on it, so why would it draw anything?
Oh, you're right. But it should show the voltage, I think. If I'm not completely mistaken. I'm probably not.
Well, the yellow, this is your voltage.
Yeah, no, I just was getting ground. Oh, so there is no voltage there. Or I'm not hitting the...
Yeah, I'm waiting for the smoke too, Rory.
No, it won't.
There's no voltage.
Yeah, there's no...
Hang on, put it on to volts DC, try again.
Yeah, sorry. The user error. 3 point... I feel a tingling sensation in my finger. What? Really? There we go.
4.5. It's not very stable.
What are you doing there? This is,
No, I think I have a bad connection because it's not that unstable.
no, this isn't.
Okay, so now it's drawing.
Can you get the grounds connected to the?
Well, it's drawing 130 milliamps now.
If you connect the ground to this thing.
Guys,
right.
that's dissipating 2 watts without a load. Can you see the? Can we put the power meter on the that? Can we put that on?
Yeah, and that's without a load.
And that's without a load.
What's going on?
Is it warm?
Yeah. Why is it?
It should be because it's nearly 2 watts.
Yeah, but why is it drawing 2 watts? Is it shorted somewhere? Wait,
Let's start again.
Yeah, let's put.
Hang on, hold on. Where are you connecting your black lead to?
The black lead is to the middle.
Okay.
So there.
So there. So that is now
2 watts. No, it is drawing 2 watts. Why? No, it shouldn't. Is this set too high?
Oh.
Oh.
Okay, I've put it towards the middle.
Yeah. Okay, that could be the problem.
Well, yeah, I put it towards the middle, so maybe it didn't like something I was doing with the.
No, even worse. 4.5 watts.
Try that.
Okay, 1.4 watts is still a lot.
So I can vary the current it draws by varying the resistor.
Yeah.
Input is on the left. You know.
Yep.
You know.
Yep.
Okay.
Yeah.
I shut up now.
I use these on my project.
Have we got one that
Why is this so hot?
it's got something to do with what when I attach this resistor, it doesn't like it. Let's try another one without anything soldered to
Get
it.
a fresh one and check a reference one.
Yeah, just in case.
Just
maybe
in case.
maybe it
An
draws.
unmodified one.
Maybe it draws 2 watts without
No.
doing anything. I don't think so.
No,
That would be crazy.
that's really hot. There's one we haven't messed around
Yeah.
with.
No. I didn't feel any heat from the ones I had. So okay. So I.
Switch mode getting hot is very bad.
Yeah, exactly. That's what.
That's getting really
Okay,
warm.
so I don't have anything hooked up.
Okay,
I
right.
just go ground.
15 volts in.
0.01. So that's probably a bad one, or it doesn't like.
It doesn't like what I've done by putting the resistor across there.
Huh? But why?
But why?
Okay, so let's measure.
Let's see the output. Let's have a look at the output.
Yeah, the output should be 5 volts.
Yeah.
So I'm going to get ground from here, and come on. God damn it! There. They're very stable.
5.01.
So something with the values we chose,
Something with me putting another resistor in here.
it screwed it up. I don't see any bridges.
I don't see any bridges.
More than the ones that should be there.
Well, we can get onto the screen if you just give me a moment.
Please go. Please do.
Just Alt-Tab.
I need to get onto the mouse mat. Right. That's what I soldered on.
So 7 and 8 were connected together in the reference.
You're going feedback to.
7 and 8 were connected to the
You're going feedback to ground, right? Oh, you're doing this parallel to the 10K.
Yeah.
Okay.
So I've got
But you could go down to something like.
well, I could go to 0.
What's the value of the pot?
10k? 50k.
Okay.
Okay, so we.
No, it's a 10k pot.
Ah.
So we're down to
We need-
5K.
if
it
we
doesn't feel right.
Yeah, no. If we remove that resistor, maybe it works. But
And you want to have probably a higher resistor in there.
Yeah,
yeah, probably.
probably. Well, I can soon unsolder that. Let's see if this one still works. Yeah.
And this, yeah, this all that it's probably dead already.
No, these things are very.
That's okay. I've just
very
disconnected the wire up here.
Okay, yeah,
No,
that should
I'm
be
there.
fine.
It's disconnected at both ends now.
Okay, so let's
Let's see if we killed it.
replace this. Put this on. The same. It sparked. 95 watts.
What? Can we get the power supply on there? On the camera?
There's no way it drew 95 watts. No, 3. Well, it's still hot.
We've killed it.
It's getting really
I
hot.
think it's dead.
And we think it's dead.
Yeah.
Okay, so no, don't just stick another resistor.
No, do some math and do it the right way.
Yeah.
Oh, okay, so normally you hook it up.
Just as you put the pot over the other resistor, quite possibly.
Mm.
Yeah, could be. So it's drawing. Now it's drawing what it should. That is less than 0.01 watts.
So can we connect a load to it and then get the
Yeah.
oscilloscope and see if we got any
Yep.
ripple? And then by then the 9-volt batteries will be charged.
Yeah, there should be
They
a
are,
ripple.
they are.
But
One,
there's
one isn't, the other one is.
120 milliohm ripple,
Okay.
I think it was.
So this is a 10 ohm. So this is about half an amp.
Yeah.
Half an amp. So
I need to put this here.
on one end on the output.
Yep.
And then we need to put the other end onto the ground.
Yeah.
Okay.
I'm with you so far.
Connect to ground.
Smoke. No. No, it shouldn't.
Now it's drawing
1.2
1.2 watts.
Out of,
High efficiency, so this would be. Mm-hmm.
and it's not getting hot.
Well, there's only 0.8 amps flowing. Now I've got like
Chris, I thought the same, yeah.
Oh, hang on. Hold on. No, I only have.
Okay, you have half of them.
I have half the load. Let me go again. 1 moment.
Half the load. Okay.
Half the load. I've got a full load on.
Should be 2.3 watts. There we go.
Uh-huh.
It's not getting hot like the other one. So the other one died with that mod. I would still think it would work somewhere.
It will. But you read the data sheet, and you don't want to go low resistance on the
On the inputs.
On
yeah,
the-
and
lower one.
on the feedback resistors with the that goes to ground. No way.
Yeah, true. That's why it said 130.
Yeah,
Actually, they went on the low end on these.
Yeah.
Yeah.
And you could tie down feedback to ground. Maybe we did this at the
So
start.
can we get the
Yeah.
scope and see if we got any ripple?
Yeah.
I think Det has the scope over there.
No, it's
No?
gone. It's actually not
What's
there.
in that black box with the yellow symbols on?
Oh.
This is the wrong one.
It's a wrong grid, is it? That.
Is this the two? Does this work?
This is the wrong one. You had the other one.
We
the
can-
one, the
okay.
yellow scribblings on there.
Let's use the other one. This is the one I reviewed. This is the 120. This one I recently reviewed.
120
Meg.
meg. Yeah, so it should be fine. The range here was 150. So no, 500 kilo.
Kilohertz. This is megahertz.
Yeah, exactly.
So this is this $69 oscilloscope that I
El
reviewed.
Cheapo something.
And
like
I
that.
did one who's quite up to about 110 meg and telling me.
Yeah, and that's good. It's just like the one I bought. It's cheap, but it's good. Okay, so let's see. Auto.
Switched on. Okay, on.
And then we go hook clip
We
on
need-
to the inputs and the ground.
Oh,
Yeah, but it's not grounded. so I'm not surprised. There we go. Oh, I dropped the load.
okay.
Okay.
So now that's empty.
Yeah.
So this is your voltage.
Mhm.
So we're on what are we at the moment? We're on 100 millivolt, 50 millivolt.
Yeah. So which?
So 50 millivolt is actually the lowest this will go to.
There's a.
Is this on the times 10 probe? Okay, so we put it
Yeah.
on the times 1
And change it
and,
here.
and then change it here.
So it's on times 10. Oh, it was on times 1. Okay, that explains a lot.
Can you choose times 1?
Yeah, it was on times 1.
Okay.
Okay, there we go. And we have it on DC coupling.
Yeah, and now let me
For
just
AC,
change this down
yeah.
to 1 volt, 50, 100, 50 millivolts. Can we send any ripple?
You don't need to go to AC.
Yeah, we need to change to AC. How
Okay.
do we do that on this?
On this
Oh,
one,
there. No.
AC, DC, right.
Okay.
So there's the ripple.
160, yeah. I had 200 on mine. So 200 millivolts.
It's saying 3 millivolts.
VPP 180 millivolts.
RMS
Yeah.
to me,
It's the VPP, you should.
180 millivolts.
Yeah.
I think this is good.
Yeah, that's not bad. The 7805 will actually have the same.
What's the auto? Is that adjust it there, mate?
The fixer.
Oh, you can see
Hey, my
quite that.
friend.
I never can see it. Yeah.
150 kilo ohms. Yeah.
Oh, 150 kilohertz. Yes.
Now
So
the-
this is the switching
Now the thing
frequency.
with this, if you can just zoom out a touch, so you can see my fingers. Right, so this is your voltage sensitivity up or down. These two are your frequency adjustment, yeah?
Yeah. Okay.
And then these two are your trigger. So you don't have to go into any menus to set the trigger point.
Yeah, that's nice.
Just having that extra up and down, you see, I can move. You see the little red arrow at the side here?
Yeah.
So that's the trigger point.
That's really good, but
Is that I'm pressing the wrong one?
for one channel.
Yeah.
If you have 4 channels, that's not efficient.
Yeah, but you can only trigger on one channel anyway. No matter
Oh,
you
yeah,
have
that-
four
that-
channels,
that is
doesn't
true.
matter how many channels you've got. So you can see the ripple.
Okay, so the ripple is not that bad. 160, 170.
Yeah.
Okay, let's change
And don't you think this $65
Yeah, no, it's really good.
oscilloscope is working
I
rather
would
well?
buy this if I didn't have my new one.
What I like about this, stupid, is just having these two buttons here.
Mhm.
Because normally you have to go into some menu to set the trigger.
Yeah.
Whereas this, it's voltage up and down, time base up and down.
Yeah, no,
And trigger up
for
and
the
down.
price, that's amazing.
Yeah.
Okay, let's put
I
on
know
the-
we have some audio guys out there. What would you say, is this feasible for audio? You probably won't use any switching mode supplies anyways, right? You're going for the linear ones, right?
I'm going to put on the linear
I'm
one.
learning here, so let me know what you think.
I'm going to put on the linear one now. By the way.
It won't work.
It should.
It should.
Well,
Oh,
well,
these are heating up.
yeah, but normally, if you put the linear one, you have to have capacitors to ground.
Ah, shit.
So we need a couple of
Right.
capacitors. So let's
Oh,
check
right,
the
right.
capacitors.
Oh, yeah, I forgot.
the...
Does it even
Oh,
stick?
holy crap, it's drawing 6 watts.
Yeah, because it's probably oscillating. Get it out of there!
Yeah, I tried. God damn it, it was not. Yeah, I forgot about the detail.
Yeah.
Yeah.
Oh man, yeah, I forgot about these big time.
The the switch mode ones ignore the design that you need capacitors. It's just
Well, they have the caps on there.
yeah, but these don't. Yeah, it does survive. To kill these things, you have to be really brutal, pretty much. Oh yeah, and 15 volts is way too much for this.
No, it's
No,
not.
no, 15 watts is fine.
No, 19.
Sorry.
19.
I think it's up to
So
40.
here's a couple of 22 microfarads.
Okay,
So just the polarity of it, you get the so from the input to ground and from output to ground.
yeah, so middle to okay, so I'm just going to do
Yeah, stick them in.
Yeah.
I told you that wouldn't work.
Yeah, no, I was thinking
Sorry, guys.
the wrong
There's
way.
experience talking here.
Yeah, I was thinking because these are always on the board anyway, so you
Yeah.
just swap these out. I didn't
Yeah.
think about that. part.
Yeah.
But live and learn.
Indeed, indeed.
I'm not a expert guru. Come on, go in. Frick's sake. There we go. Okay, so
You got your capacitors on there, input and output.
yes, I do.
Right, now stick your regulator. in.
7805.
This reminds me of me playing around with I2C. And
Can we get the camera onto the bench power supply
So I don't kill it.
so we can see what wattage it's drawing?
Yeah, so I kill it on camera at least. So it's in. Oh shit!
Oh.
That's still way too much.
Try another one.
These are not.
These are pulls.
These are not very efficient, obviously, but 6.5 watts is a little brutal.
do this without the resistors. Start without resistors.
Yeah,
and see if
remove.
Okay,
they-
remove
if they
the
get
load.
stable 5 volts.
Yeah, maybe it's just a load. Because
What,
these
half
are.
an amp? These are rated to 1 or 1.5 amp.
Yeah, but these are not efficient at all.
Okay,
So-
size.
Okay, so let's see. Did I kill it? Yeah, now it's not drawing anything.
Okay.
So it was the.
What's
load.
the output voltage?
It's.
You got a meter?
Yeah, we did.
Yes.
Yeah. Scope. We have it.
Meter.
We have scope.
There was one. I remember.
Crap! I stabbed myself.
Oh, stabbed in the guts with the yeah.
That hurt. Okay, let's see. So input voltage from middle to here. Yep, 15 volts.
And on the output,
Okay, I should not touch those together. And the outputs, I'm measuring the resistors. Yeah.
4.88, so it's not as good anyway.
Yeah.
Right, let me turn the input voltage much lower.
Yeah, so the accuracy.
So let's take the input voltage down to say 7.5.
You
Yeah?
sure this works? 2 volts is enough for the.
It should be 2.5.
Yeah, it
this
gives
old
the
design?
same. It gives the same. Oh, sorry, I'm missing the.
So straight away we can say the digital one, of course digital, the switch mode one,
Yeah.
is more accurate.
Yeah.
Right, let's connect the load now. So what's the power supply on the bench? Do you want to measure the voltage on the output?
Yeah, I can do that.
Thank you. Maybe put it somewhere there so people can see what you do.
So that's the
wait. There we go. Yep.
okay, and can you see the current is drawing on as
No,
well?
I can't get this all in shot.
I bet
Okay,
you
so-
can, just like that.
Yeah, you can see it somewhat.
Okay,
Cool. Okay. There we go.
okay, now we put the load on, yeah?
3 watts.
Right, we're on. Now it's giving 4.88.
Yeah.
Mm-hmm.
But
So
it's,
the same to stay the same.
Yeah, it stays the same.
right, so your problem was that on the higher input voltage,
It actually draws more. It's the
It
7805 that
it's
actually.
5 watts now, yeah, because it's a linear regulator.
Oh, this is getting hot now. It would get
Yeah, it's not. So the fact is, in fact, that the switching one is far better.
Yeah, it is.
Oh, let's see what the noise says, the ripple says.
Yeah. Okay. So we have the load on, and we have this connected, right?
Yeah.
Yes, it is connected. So let's check the noise auto. And it is on AC. Yep, it is.
There isn't any.
Mm,
19 millivolts.
No, it's still adjusted.
no, it's
Oh, there
still
we go.
400. Yeah. So
No,
that's
wait. What's
yeah,
this
but
is
where?
AC?
VPP 400.
You're still on DC.
No. It's on AC.
Yeah, we said RMS is 0.
Okay. Oh, yeah, true.
It is on AC, and no, it's not 0. It's just that it's out of range.
I don't see, I don't see any ripple.
5 volt is, you can't measure this in 5 volt.
Oh, okay, let me, okay, well, those.
It's jumping.
Yeah, it's going something on.
That's your noise now, yeah?
Go further out, and you will see. It's. I got the memeasurement.
Yeah, this is what I expected.
Yeah, there we go. A lot less. Yeah. Okay.
So we're
go
down
on,
to
Wes.
something about. Oh no! Don't do the audio thing.
I just want to see if it fails.
Yeah, but it's not.
It's on 1x. That's why I wanted to see if. No.
It's thinking about and thinking about. Right, it's on
Yeah,
to 5
so-
volts now again.
Yeah, so it goes to 5 volts. Yeah. So it doesn't find any ripple. That's why it stays there.
This is noise rather than ripple. This is
Yeah.
just
Yeah.
This
like
is background
noise.
So the ripple comes from the electronics in the ZX then on my side.
Could be.
Yeah.
Yeah,
That's
but
it, because you're constantly changing loads and.
Yeah.
Yeah.
That gets hot, really hot, so be careful.
Yeah,
Mine was at 80 degrees constantly
right.
on the ZX.
So, guys, which is the better? The switching one with more ripple, or the 7805 with all the various things? It doesn't like too much input voltage and too much voltage drop.
200 milli. I measured the ripple at the ZX, and actually I got a reduction with the switching one.
Maybe it's reacting better to the changing.
Yeah,
Load
if
in
the load changes.
Well, so how does that noise affect if I turn the power supply voltage off? If you get back onto it again, so you can see that noise,
Okay.
and I increase the input voltage, yeah?
Yeah, so it has to work harder.
So it has to work harder.
Okay, so it won't smoke until it gets to 150 degrees or so.
Okay, so I've now upping the input voltage.
Yeah, 12.
It's drawing 5 watts.
So it's still jumping out.
I'm going some more. 6.5 watts.
Can you change the time base? 50 microseconds sounds a bit.
Yeah, 200.
Let's see if I can see more.
Yeah.
Okay, so I'm increasing the input voltage again.
I'm trying to find. Yeah, there we go. 1 millisecond should be.
I'm
fine.
at 15, 16 volts now.
Yeah. Yeah. Do not touch the 7805.
It's drawing 5 watts.
Yeah. Do not touch it. It's going to be burning hot.
Yeah.
Okay, so there is no ripple actually from the 7805, but with a switching input and output, or a switching output, maybe there will become one.
Okay.
I'm guessing.
So,
Okay, we got some people coming in. Depends on what you're going to do with it. Yeah, absolutely, Carter. Yeah,
So-
75 is my choice all the time. Really, you use this old design. If I go for a linear supply, I normally use some of the current designs because they probably come in a SMD package, way smaller,
Way more efficient
way more efficient. Yeah,
I think,
7805 is something I try to avoid.
from the 80s.
can I say, if I'm repairing something, I'm not going to replace a 7805 with one of these.
Yeah, I know.
If I'm actually doing a repair and there's a 7805 on there that's faulty, I'm going to change it and put another linear 7805 in. I'm not going to fit one of these switching
I
regulators.
actually did this to improve the electronics because
But you
because
did.
of the heat.
Yeah.
Because this was constantly at 80 degrees, the 7805,
Yeah.
and it is designed that way. I was not the only one on the internet.
We can see that.
But these were about 30 degrees when they were
Yeah.
full operational. So, and where
Maybe I'm wrong then. It's just
in the ZX Spectrum, the problem is the heat degrades all the components inside. There is no fans inside, and it's connected to a humongous heat block. So it spread out the heat everywhere. So the keyboard membrane dies over time.
Okay.
So yeah, no, I would go the switching one where heat is a problem. If heat is not an issue, let's say inside the car.
I think
Go for it.
my own project, which is almost like you doing a mod,
Yeah.
I would go with a switching one.
Yeah.
If I'm repairing some existing device,
If you
I
want it
would
stock,
leave.
yeah,
Because of that noise,
yeah.
I'm not sure whether the device was actually still operating as
It
intended.
depends on the device and the filtering inside the device.
But what we didn't try was the digital one while we've got these 22 microfarad capacitors in.
It shouldn't matter.
It
Should that reduce the noise?
It ignores them completely, I think. We can test. No issues to testing. Yes. Okay, and I'll hook this back up. Let's see.
Power supply back on.
So this was ground.
Does because
Chris
obviously
just said, can we check the output with the caps on it?
which is exactly what I just said. Yeah.
They
That
weren't
thing?
working.
Get it to the right place.
Voltage is at 7.
Well, put it back to about 50 where it was before.
at least 8. It should have
12.
According to the data sheet, at least. Okay, so it's in. It's drawing 0.01. So the output is not connected.
Let's have a look.
Yeah, the output is not.
Well, that's ground, and then
Whoa, that's a lot.
yeah, the load's on.
So it's actually more ripple.
Okay, is it fighting the
It's fighting the actual
cap?
the caps. So let's remove them live. Okay. So I'll remove the input cap first.
It wouldn't do anything.
Yeah, exactly. No, that's what I expected. And then the output cap.
I
would
bet
be
nothing
the-
happens.
No, it's
There's something not
Something
really
not
good connected.
something.
yeah. So the connection is not great.
Where's this go to? This black clip lead. Supposed to go somewhere. This is ground to your scope. Oh no, this is ground to your
No, this is
load.
power.
Where's this thing supposed to go?
It's not grounded. That's why it's showing that much noise.
No.
This looks better.
Yeah, okay, so let's put back the caps.
Please do, yeah.
Okay.
So 1/4. That's lower than before, isn't it?
No, it's the same.
Same.
It's the same. Okay.
So polarity, obviously.
Yeah. I'm going for the input first.
Won't do anything.
Won't
yeah.
do anything.
Yeah, no, that's what I figured. So,
Output.
and output, yeah. Let's see if I get the holes right. Yep.
Does it make
It went down
Okay,
a
let
little bit.
me try putting a 100 nanofarad on the output as well.
This is a arbitrary value, so you probably have to select a cap for the
Tuning it, yeah.
the 152 kilohertz.
Okay, Carlos.
Yep.
Can you get that onto the output as well?
Yes.
A 100 now.
Yep, okay.
That will help.
And this is non-polar, so
This is non-polar.
and the output.
Ground leads jumped off again.
Yeah, there we go.
It doesn't like to be grounded.
No.
So we can get the 100 nanofarads on as well.
Yes, give me a sec. I'm trying to eyeball it. There we go.
Doesn't make any difference.
Mm.
No, not really.
No, it's not in. Well, that's why. It bent the lead back.
Okay.
See?
Yeah, I see.
God damn it. I thought it went in. It felt like it. So, do we keep the resistors that are on currently? Yeah,
Yeah.
right. Yeah. Or no, capacitors.
You can do. If you need to take that, take that out. But
No, it's in.
so no difference.
It actually went up by about 0.5 or 5.
So
Yeah, it actually goes down if I remove it.
okay. Okay, so it doesn't make a lot of difference.
Okay, so if we do this
Technical caps level together
and put
just put the 10.
and this is a high frequency one, so
Yeah.
should be better.
So it's 100 nanofarads, not 10.
It's actually up.
Yeah, it doesn't like the 100 nano.
Yeah.
Again, check the data sheet for this.
Yeah, probably.
Yeah, reference designs are there for a reason.
Yeah, so probably it's likes a certain range.
Yeah.
So if we just put in one, let's say just the output, that's exactly what I did on my RGB amp thingy. Yeah, and it goes down. Okay, so
Yeah, Embedded Hobbyist says right. I fit an inductor before the output cap to make a Q filter. Yeah. So if you need a switch power supply and you need a low ripple output, this is probably the way to go. But this is a lot of fiddling.
you can solder it across the pins, pretty much.
Well, if you're going for a
sort of fiddling.
solution that is on a PCB,
Yeah, but
there's
we
a lot. There's a lot of,
why not just design our own with
with
the solution on?
Again, this is what I'm saying when I need a
Yeah.
power supply for something. I normally
Yeah.
go for these designs because they work. They approved.
What do you say, guys? Would you buy these from us if we made them better?
Don't, because we can't make them really
No,
much better. And they probably would cost 5 times the things when they buy them in China.
We have to buy them from LCSC, probably
Yeah.
all the parts, if we want to even compete with 50 cents each.
Yeah. This is so dirt cheap. That wouldn't make sense for us to design these.
But soldering a capacitor between these two legs is not hard. And these don't go all the way in. You usually go this deep.
I'll stay with the guys. They say it depends on what you're doing with
of
these.
course.
Yeah.
If you need the precision.
Agreed.
Yeah.
Agreed.
If you need a ripple free or as ripple free as you can get with a switch mode.
Probably
Okay.
go for linear then.
So
Yeah, the true. If it's that necessary, yeah, maybe.
well, we have about 10 minutes. So are those batteries charged, those PP3s?
Yeah, they
Oh
are.
yeah, they are.
So if we connect a load to one of those and work at the ripple on the output.
Let's clean up the desk a bit.
Yeah.
We are going. Okay.
Only a bit. Nothing too excessive.
Yeah, no, that's fine.
I can't see the desk anymore, man.
We need to turn this off.
Oh,
Okay.
this is the one with the switch.
I have the load here. We need the load.
Yeah.
So we want the.
Okay.
We want one of the batteries.
Yep. And we need the oscilloscope.
Oh.
I saw you putting it away. Come on. Okay. There we go.
Okay, they should be charged because green lights. Can you see the green lights over there?
Yep. So that usually means charged because they were red before.
Yeah, and we're getting pretty warm. This is
Yeah,
really...
they're not hot anymore. So at least they start a trickle charge when they get full. So that's good. Let's do this.
Okay. I'm going to just adjust this load so we now have a 40 ohms load.
Okay.
So on 10 volts, that'll be about 250 milliamps. That's probably reasonable for these batteries.
Yeah.
Yeah, so.
We don't want to overstress them.
No, we have enough load for 250 milliamps. So, first of all, is there any ripple on that when you connect your oscilloscope to it?
Yep, let's take a look.
Just does it actually.
First thing, this is output 9 volt now.
Yeah, does that put 9 volts?
Yeah, we can check.
Yeah, you can use the scope. Yeah, sure.
Or you can use a meter.
Yeah, okay. Meter. Here we go. Your nice fluke. So the big one is groomed.
What am I coming up with?
Yeah.
9.35.
Yeah, that's the problem. Because this keeps up the 9 volt on the output all the time. So,
What's that? Excuse me. A battery.
yeah, I know. But the buck converter,
this switches all the time.
the buck converter side is active now. So it is active while you put it in the
I'll
shell.
bet this is active in the same way that, like you say, a power supply
Yeah, sure.
switch mode is. But when there's no output, they go into this kind of mode where they're just triggering the MOSFET every so many
Yeah, true.
cycles.
What you would see is there's a cap.
What you will see is this will discharge.
Yeah.
So will there, can we say
But
ripple?
over time, this even if it's just some microamps,
It
will
will
discharge.
over time it will.
Yeah.
So these are not good for long-term thingies.
Yeah, I'm with you. Yeah, I'm with you, guys.
Okay, so DC. No, we need
No, AC, we're just looking for a ripple.
Yeah. Yeah. No, I'm just setting it up. 1x should be fine.
It should be the same as before.
Yeah. So there. Huh. There is no ripple.
No, there is.
Yeah, but very little.
Yeah, but because it's in this kind of like intermittent switching mode. Look, it's there.
It's 50 millivolts, but that's not bad.
So that's without the battery connected to anything.
Let me get close here.
That's a sawtooth ripple, yeah.
Is that a sawtooth ripple about 100 kilohertz?
Yeah, this is the switch mode system.
So
the boost converter.
But
inside.
it's better tuned on the other one. But
Okay.
yeah, this only delivers 1 volt.
Now
There's no load on there, right?
Well, let's put a load on.
Oh yeah, right. I forgot about that.
So this should give us about 250
Can you move the
milliamps.
scope over here?
Yeah, wherever you like.
Sure. You can take it. I just need to straighten.
Sorry
out
for
the
the vomit-inducing camera right now.
Yeah, I'm just going to straighten out the cable so I can actually measure stuff. Okay, there we go. There we go.
Okay, so we now have this is the load. So connectors across the battery.
I did. Okay, and
So doing this over there.
measure.
And what do we get?
Yeah, the ripple is a lot worse.
Because it's running out the high frequency. I told you this would happen.
Yeah.
It's actually switching continuously. There you are.
Yeah.
At 1.23 megahertz now.
Ooh, this is fast.
That's really fast for one of these cheapo thingies. It's getting hot. That's my worry with these things. No, it's not.
Well, I'm drawing about 250 million.
Yeah. So that's fine, but they can still heat because of the chemicals inside the batteries. But no, it's not heating up at all.
Well,
And it's not that bad.
Well, let me just I'm taking the load
This
off.
could be
That's the
worse.
load off. Now I'm going to put it down to double the load.
Oh yeah.
Okay, so the switching
That's about 500 milliamps.
is different. Yeah, so
This still works out, and
the ripple is a lot higher though.
Yeah.
yeah, it's doubled. It's doubled in size.
Yeah, this is back to the before, 250 milliamps.
So the lower the output, the lower the. Okay, I'm fine.
So shall we try to draw about an amp on this?
Yeah,
Okay, so just give me a second.
it should be able to.
Should supply about an amp. Okay, just give me a second while I just connect the load and the amp.
250 then.
Well, we're now going to 10 ohms on the load, which is, should be
Wow.
just over 1 amp, yeah?
Okay,
Ready?
An amp over this. This is
Go.
wow.
Yeah, 250. So 400. Okay, so it has a limit.
Half a volt. Okay, half a volt ripple now. So
Yeah, at 1 amp.
this isn't
Yeah.
happy.
But
This
a PP3
wasn't happy.
battery is not designed for applications
No,
with 1 amp
no.
loads.
You don't draw 1 amp with these.
No, usually you don't know.
Yeah, no.
But it's interesting to see how it behaves.
Yeah, so the ripple is not bad at all until you get to about half an
Half
amp.
an amp.
Yeah.
But I say that. But I know what you're saying. You put this on your multimeter or something, and it's just going to go flat.
Yeah, it will.
It will eventually.
Well, probably not.
Maybe 3 months or something, and
Will it last that long when it's still running effectively?
yeah, as the frequency went down to 100.
Yes, it's running in like a pulse mode.
So
yeah. But it was still Dutch leaving, and Chris already has left the building.
yeah.
Pua, you're right.
Yeah.
You know, for the right application for a guitar effect thing,
As-
Chris talking about.
As long as you hook it up from time to time to charge it and you use it actively, it's
How
no
much
issue.
were they, Jet?
Oh, I don't know. These weren't cheap.
No, these are about 15 euros each.
Do you know what? I just buy myself a PP3 battery for €1 when it goes flat. I buy another one.
Yeah.
That's
So-
what I would do. I just keep a spare one or two.
So these have this inside a lithium battery.
Chris says about 2 months, and he had some experience with these.
Yeah, you're probably right. You're right on the mark. And 2,800 milliamps.
Well, let me show you guys.
I really don't think.
No, this sounds a bit over.
Yeah, considering the weight, this is maybe 20 grams.
You said something. There's a seal that maybe can break.
Yeah, there is a seal right there. See.
Can I answer Rory? Sorry, Rory, didn't see
If
the
you
message.
have a knife, Richard, I can open it without breaking
It's
it.
debts. And you have 3 minutes. Rory, yes, it's a single channel scope, 120 megahertz. I connected it to an RF generator and it was working quite happy at about 105 megahertz, showing me the sine wave and telling me the frequency.
Yeah.
And they're about $65. You'll find the review of this on my channel from about a week or so ago. It's the tool top this thing.
Is it that?
ET120M Pro, and I think for $65 or $69, this is not a bad bit of kit.
No. It's useful.
It's useful.
It's
It works.
isolated.
It's isolated, great for doing. And the last thing I like about this, and this is what you said about batteries,
It's a switch.
this switch, that is an off switch. Off is off.
It
I
cuts
like
power.
this. I really like it.
Off is off. We've
Yeah.
forgotten this.
Yeah. So cutting power with a real switch and not a momentary one
Yep.
is a lot better.
Off is off.
I really
You
like
can
it.
stick this in your tool bag once you've charged the battery. When it's switched off, it's off.
Yeah.
You
it
take
won't-
it
it
3
won't
months
rain.
later, you can switch it back on again.
Yeah, it won't rain. It has a port here.
Yes, for charging.
It's the charge port.
It's a USB-C charger, but off is off.
Yeah, that's really good.
The fixer asks you if they get the manual for the Nano 600, whatever this is.
Oh, right, okay, so somebody sent me a manual for the Nano 600, and, sorry, a repair guide, schematic. The one I have says it's from 2003, if you look at the information in the bottom left, bottom right-hand corner. That speaker of mine from about 2015. So if you have a manual, you think for this, have a look where it says 600 HK. If it says it's 2003, unfortunately it's the wrong one. If you have one from about that time I have, please send it to me.
Is this the baggie for this?
I think it's a baguette for this.
Oh, giveaway. So, okay, right, the giveaway. So,
Isn't this a secret?
right, no.
Okay.
Okay,
The
so
giveaway isn't a secret.
the giveaway isn't this week. We're doing 2 broadcasts in April. One on the 7th and one on the 21st. Okay, I'm going to speak with Banggood tomorrow and ask them which of those 2 dates we're going to do the giveaway, and whichever one they say, because they said they did want it in April, it will be. So either the 7th or the 21st of April will be the giveaway. And I announced on my channel, the other guys do the same on theirs.
I didn't have a clue we had a giveaway.
Now you know.
Now you know because you've been sick. We
Yeah.
have one of the Gotti Fix scope meters to give away. Gotti Fix scope meters to give away. Okay, so guys,
Not bad.
Thank you for watching.
Was fun as always.
Yep.
Hopefully we'll be here next time. We didn't bore you too much.
yeah, and I'll let you know tomorrow or the day after if the giveaway is going to be on the next one or the one after. It's going to be on one of those 2.
Yeah.
We will. Okay, guys.
And there went the beer.
See you in about a fortnight.
Yeah.
Yeah.
Is this a fortnight?
It is a fortnight.
Yeah.
It's 2 weeks. So yeah. I didn't know what the fortnight was until I saw the game.
It's not a game.
No, I know.
Yeah, and
It's
Richard's
not-
crabbing up now, so we cut the stream now. Bye, guys.
Bye.